Cheese.
Welcome.
Cheese.
Stop. Oh my god, Omni, why are you?
It's another Prime subscription.
Thank you very much, Lick. Welcome. Thank you very much for the reason. How on earth has it been 31 months?
Jeez.
What is going on here? But hello. Okay, I guess I'll continue saying hi after the break. Aw, thank you for the pants.
Cheese.
How dare you? Welcome in Shika. Welcome in TTH Bonmas. Lick. Midnight Cat. That's what it says, yeah. It says Midnight Cat right there on the screen. It doesn't actually, but yes. How long has the long week been opening the dot on the eye? Not that long, don't worry, it's not embarrassing. Maybe like a month? I feel like it's not more than a month. Welcome in Alex, welcome in Bonmas, welcome in Omni, welcome in... nobody else. Anybody else who's looking. Oh, Teddy! Hi, welcome. Oh my goodness, I almost missed. Hello, hi. How are peeps doing? Thank you for the pets. Aww. Thank you, Bon and Chic and Otter. All for the pets. All for the pets. Okay, I have a Nyan. Hold on a second. Nyan. Quiet Nyans only. We're in quiet mode. Very quiet mode. Maybe a little, dare I say, liminal with the music? I'm actually trying to do air quotes, but it looks like I'm trying to go mwahaha due to the infamously fantastic motion hand tracking. Anyway. Hello. Hope people are doing okay. I'm glad I was finally able to push my ass to stream. You casting spells at us?
9.
9.
Shadow Wizard Money Gang. We love casting spells.
Did I get the correct round? I never remember. Is it Shadow Wizard Money or Shadow Money Wizard Gang? I never remember which way around it is. It's like two random words. It was correct. Nice. Hell yeah. Thank you. I've noticed my ears are being like so incredibly flicky recently. I only noticed it when I was on Omni's stream recently.
Why do you believe it's Yuko Clock?
It is Yuka Clock. Keza. Oh no, she's struggling. She skipped the one letter she didn't know how to pronounce. Amazing. It's basically that, right? Thank you, Teeth. Thank you to Pat's Pass and Crazy Kitty as well. Hello, welcome in Jokeber as well. Hi, and Vegnacht. Hi. Oh god. I'm bunking the mic already. Yeah, I'm feeling a little run down at the moment, and I was feeling even much more run down yesterday. So I don't know if I've like caught something. It doesn't really feel like a cold yet. There's like the faintest hint that maybe it is, but I don't know. People in this household... People in this household have had like 2 colds recently, so I guess maybe my body is like fighting it, but it's not like reaching my nose or throat yet much, but I do feel it. I've been going like very cold and very hot and without much time between them yesterday, so yeah. Bix! Hello! Hi! Welcome. I also have some tea here. It's very rare that I drink this, not least because I don't have a model for it. So it's just an invisible thing and you have to trust that I'm actually drinking something. Let me drink cartoonishly loudly so that you can tell. Aerated tea, my favorite. Thank you for the pants, Nax. Also, hi, Big Sayu. I know I already said hi, but I'm gonna say hi again because it's so nice to see you here. For some reason, I haven't been seeing you much recently. I mean, I don't mean just like in my stream. I mean like we just our paths haven't been crossing much, and I was missing you a bit. So, hi. Hope you're doing well as well. Invisity as well. Yeah. It's the first cold snap. Please don't get ill. All yeah. I'll do my best by staying shut in my room the entire time. Like always. So anyway, yeah. I need to close some tabs. I didn't realize I still had some stuff open. Get out of here. Stop playing my stream. Stop wasting my bandwidth. Not being very social lady. It's totally fine. Like, don't push yourself or anything. It's nice to see you.
When will the Yukideka Macro become available in your mod shop?
I'd have to commission some nice, tall, high-resolution art for that first. Well, come to think of it, there kind of is some...
Formaggio.
On my face. There kind of is some, there is that really big, like, non-artwork piece by Cat, which does have a very, like, a tall and I guess high-ish resolution. Probably not high enough for a Dakimakura though. Picture of me on it along with Enlin, Bix, Cat, and other people I can't remember at all. Amazing. Yuki Makura. Hi Neo! Hi. But yeah, I hope you feel better socially soon, Bix. So, I'm hoping to be able to get back into working on my Petlong uke. 2 hands, please. Please leave motion, please. That was me knocking it, which is obviously how you fix anything, right? You tap it a few times. Mic's not working. Tap it a few times. T's not working. Tap it a few times. Just seeing if I've missed any redeems. I don't think I have. Machine spirits like to be tapped gently. Yeah. Make sure you tap your Nova whenever you see her. So I'm hoping to get back to my so-called Petlong Uke project soon. This little digital pet Tamagotchi-like thing, except it's a lot more than at least the Tamagotchi clones nowadays are. I don't actually know exactly how they were back then because I didn't have one, but I had a friend who had one, so it's all a very faint memory. Do not tap the screen, you'll scare the viewers. What do you mean? I was trying to tap both at once. Oh no, now my hand is stuck up. 6 kilo hammer. Okay. That's not a light tap. Hi Saito, welcome. Hello. Hi. Ticketmaster just really needs to go away. I don't know what happened. What's happening? What is Ticketmaster? I've heard of it. Is this like some service for like selling concert tickets and stuff? Or is it like train tickets and stuff? I don't know. But yeah, I don't feel like my brain is super up for doing coding tonight. So I'll probably just slowly try to get back into maybe what I was thinking of doing is you know, let me press the button, I'll show you what I was looking at. Boop. So this thing here is a picture that I sort of threw together during a previous stream. It's to do with like a circuit that can allow the microcontroller to run for just a small bit longer when the batteries get pulled out, so it has a chance to save its internal state, so that when you put a new battery in, the long nuke can continue like in the same world with the same stats and whatever. I don't think there are going to be many stats, but you know, just in case. I just can give it time to save a few bytes to its From. And I was thinking, bye-bye, so I told no worries, it's 2 AM, I'm just kind of hopping in to check. Yeah, no worries, have a nice sleep, I hope you managed to. Also, hi, Seal as well, welcome. Feeling sleepy and drowsy, just defuse bombs. I might not mind trying to play Keep Talking and Nobody Explodes, but that's probably not the best thing to play when I'm, like, trying to be quiet. Also, hello Fox! Welcome. To create a passkey to sign in to their app, I had to install their app. Or uninstall their app. Wait, that sounds like a win. You missed the tail? Oh, I'm sorry, hold on, let me. There it is. Wish. Ah. Bredig! Hi! Welcome, Dara. Hello, how are you doing? Thank you very much for the resub. 39! You've almost reached 40! What is this? Holy crap, you're nearly middle-aged. Fine, I guess I deserve that for saying that.
Cheesy.
What happens if I put on this view? Oh, okay, that's not great. Never mind. Sorry, go over and see. What a beautiful tale. Thank you very much. I might also have to go. Yeah. For the oct. Thank you very much for the resub, Dara. Hope you're doing right as well. Hoi. So what I was thinking is, cheese. It's cheese. I actually ate cheese on crackers just before I came upstairs to stream. I thought 40 had been regarded as middle-aged since I was a child at least, which was... I won't say exactly how long ago, otherwise... Anyway, let me drink some more of this. Is that my Mexican-Spanish cousin, the author of that song, El Dera? What? I know what that is. No comments, Chris. Hi, me. Welcome. Am I having a birthday? Not today. I tend to have birthdays semi-regularly, though. It's like maybe once a year, I think. So what I was thinking of doing is maybe remaking this circuit in a little simulator and seeing if it even works, because I haven't even tested it. Oh, the song's artist, yeah! Look at that. I can't make it bigger on the screen, sorry. Best I can do is take a screenshot and zoom into it. Same with this. Yeah, that is what it says. That is certainly what it says. Yeah. Bread 39 because it's 39 months. 39 months of sub. I think is why Dara said that, Neil. But she reads it as Bredig, as if it's lead speak. Ironically, not being able to pronounce the name, the word lead. 1337. Anyway, let me get up the little simulator thingy, and I guess we'll try to see if it works, question mark? I guess I'll do a little rundown on the idea of it as I go along as well. It's funny, I get so hot when streaming. I think it's partially like the mental state I get into, and also just the fact that there's more stuff on making heat when I'm streaming. The number of times I've thought, you know what, I'm kind of cold already. I don't need to like put a fan on or take off any layers of clothing, and then I start streaming and like within 30 seconds it's like, well, time to strip. I just had to turn a fan on as well. One sec. Okay, I'm back. Thank you for the hydration and pulse check. What are we doing today? Hi, Monkey. Well, I'm about to be beginning, and I'll show you. Thank you for the hydration and pulse check. Let me do them quickly. It's a cup of tea today, Dara. For now, anyway. There's bottles as well. Ah!
Kaseraki.
Bottle of waters. Next, because the cup of tea is not going to last my entire stream. In fact, it's already getting kind of cold. Lukewarm, one could say. Hi, Sis! Welcome, welcome. Oh, posture check as well. Why, jeez. Okay. So. Drinking warm tea from plastic bottle? No, from a mug. Listen. Had a bit more since I was holding it. So yeah, well, the idea is that this little Pedlong nuke that I want to make will be running on this microcontroller, which is called an STM32. It's like an ultra low power one, so it's like going to be pulling less than a milliamp. I think it's pulling like around 200 microamps on average. And it can go into a very low power sleep mode where it uses technically it's supposed to be able to go below 1 microamp, but how I've measured it with the things that I require still turned on inside it, it takes like a couple of microamps. I'm not sure exactly. Anyways, it's basically nothing. And it sounds like the light bulb in my brain when I'm about to form a thought. It's like the fluorescent light that's about to turn on, right? I really like the sounds of those bulbs in what game was it that I was noticing that with? Superliminal. I haven't played it, but I've watched a bunch of people play it and those sounds stuck out. I have a mug with a hot plate. You are the second person in less than 24 hours to bring up mugs with built-in hot plates. It's a very bizarre coincidence right now. I'd never heard of them in my life before, but... So anyway, so yeah, it's going to be running on like, I think it's probably going to be 3 AA batteries. We've got ourselves O1, O2, O3. And then, they go through into this little thing, which is a voltage regulator, which is going to take it down to, let's just say 3 volts. Crazy idea, but hear me out. What about a hot plate with a built-in mug? Maybe. You're living in the past having a hot mug with a cold plate. Yeah. It's like I have to put the mug onto a cold plate. I don't even have a built-in one. I could put it on this. It's my sound interface. It's not even that cold, to be honest. Maybe I'd keep it warmer if I put it on there. Let me do that. It's kind of loud though. Also, if I knock it over, it's going to be really bad, so let's not do that. Thank you for the pads. The PC can be hot plate? Yeah, that would do the job. It's already like the temperature of the air that's coming out of my computer. It's already the temperature of the tea. But I can't easily reach it, and I will definitely spill that when trying to grab it. It's awkward to reach it around like that. Thank you for the pads. I'm not alone. Thank you very much. How are you? What is this emote? That looks... Oh, it's thinking. I thought it was someone with pink hair and like a maid headdress around the top when it was small. But no, it's like blue hair. That is what I thought was a headdress, and the pink that I thought was hair is actually a brain. I don't know what a brain is. What is a brain? Can someone tell me? Don't say a miserable pile of secrets. The mug is completely flat on the bottom to contact the entire plate. Wait, I thought you said it had a built-in one. Fine, but I'm so tired. Oh, I'm sorry. Okay, so this regulator requires 2 capacitors to work, according to his data sheet. Wait, why am I drawing in like the thinnest fucking... Okay, there we are. So it needs these two. So these are just to make the regulator work. And on this side we have a voltage that's like gradually goes, you know, it's got a range of values that it could be the battery like gradually, the voltage gradually drops over time. And then once it's on the other side of this, it's like nice and continuously around 3 volts until this side gets a bit too close to 3 volts and it gradually, this will start to sag a little bit, but not much because it's sort of low dropout oscillator, which resists that. Anyway, having Yan right now. Yan. Thank you. Or rather, I hope the Nyan is satisfactory. Life is so hard. Yeah, it is. It is. But I wish you luck. So are you creating a double of yourself so you can pet 2 digital cats instead of 1? It's more like so that you can pet this little creature. A long eek. Or this if you simplify the drawing a lot. Oh, hang on, I've got it loaded right here as well. That's the actual sprite, as it currently is. A boat? Shh. I don't know if a long eek could float. It probably would. I don't know if it would swim very well though. Hi, Israel as well. So once we're on this side, all this stuff is going to be seeing like roughly 3 volts. But what if the battery is suddenly pulled out, right? Oh, by the way, the power then goes into the LCD, and also sometimes when it's playing sound, it'll go into the amplifier as well. This will get turned on and off by this, because this idle's using like a lot of power, like 10 times this plus this combined. So it's going to be off the vast majority of the time. But like everything here could take, I'm considering this like the high current area, like the high power consumption area. Thank you. It's like the ferret Pokemon? Maybe, hang on, let me show you a video. Where are we? Photos, I guess? This one? No, that's audio. Nope, that's rain. There she is! Look! This is where we ended up as a test for animation and drawing the long uke from parameters and stuff on the previous stream. And this one was a test of drawing snow and rain, and the rain actually appears behind and the snow appears in front and stuff. I don't know what this one is. Ah, this was the test for handling button inputs and repetitions and stuff. Anyway. Rat mode? What do you mean rat mode? Hi Meatloaf, welcome. Wait, is someone off to sleep? Oh, sleep well, Dara. Thank you very much. Thank you. Okay, so, when the battery suddenly gets disconnected, this is not for, monitoring the battery every now and then just to see if it's, you know, to monitor the gradual discharge of the battery and show like a low battery warning or something. This is not to handle this. This area here is to do that monitoring. Yes, get a load of this here weird cat. Thank you very much for the resub, Trade Splatter. Oh yes, the rat's nest. Also welcome in. Hi.
Wow.
I forgot how she says lol. It's just
Lol.
Yeah, it's quite the rat's nest. This, I'm quite scared about this. As in, like, I'm scared of accidentally unplugging something and then having to try to work out where the hell it was plugged into. So when the battery gets yoinked, we want to be able to keep this running for a little bit longer, right? Like, it only needs probably a couple of tens of milliseconds at the most to, like, save the state. Probably less than that, actually. I don't know what the speed of writing to EEPROM is. I should probably find out. Anyway, EEPROM is like a section of memory inside this that gets preserved even when the power is cut. It's non-volatile, but it can only be written a certain number of times, and there's very little of it. I think there's 1 kilobyte, there might be less, but that's far more than we need. We should only need like a very small handful of bytes. We basically just need to store the random seed the world was generated with, and I guess this is a current frame number or something. I'm not entirely sure how the random world generation is going to work exactly, but can that be sort of debug probe one of these days? Maybe? I guess that could be useful. I mean, I feel like it's going to be less useful because I'm messing around with CPU speed all the time, and I guess that might mess up the debug thingy, because that's probably going to change the baud rate. And I'm also using sleep modes. Although I do know that the debugger something or other can keep running when it's in the sleep mode, if I remember rightly. And I think you can set timers to keep running when the debugger hits or something. I remember there's a bunch of settings to do with debugger. I actually don't have any communication from the microcontroller to the computer at the moment, or vice versa, except for when I'm uploading code. I haven't bothered to like get serial output working yet. The debug stuff lives in its own thing. Changing the clock shouldn't be an issue. Oh, that's kind of cool. What the hell? Okay. So we want to keep this running for a bit longer. So there's a capacitor here, and this is like a bigger one, and then this should keep this running. And then I want to put this diode here so that this capacitor, when it's normally the power from this, right, can go into these, and then also continue down into this and power stuff, and also keep this capacitor charged, and also power this up. But when the power gets cut, if we don't have this diode here, then this capacitor could like discharge in this direction, and like these things could steal its precious current and make this run for less time. So that's why I've got this diode here, so that this capacitor can only keep this running, and its charge won't get wasted on these things when we need it. And then I guess when this is finished saving things, it should probably go into like a high, I probably want it to like pull as much current as possible in order to like finish off draining this capacitor. Because what we don't want is for the power to be able to come back on, and this has already entered its mode of, oh no, the battery's run out, but it hasn't actually fully turned off yet. Because then when you connect the battery, this will do nothing, if you know what I mean. So we sort of want to do what we want and then fully drain it, so this like turns off fully, so that when the power gets put on, we start from a clean slate from the beginning, and I guess we'll have something to look inside the EEPROM and say, oh, looks like we are running, let's resume from there. Rat! Yes! Hi Chris, hi Eeg, welcome both of you, hi. Time for a bit more tea. You know what, I'll just finish it. It's at that point where it's like, there's such little left that it cools down really quickly. Okay, nice. And this, I wanted to make a Schottky diode so that it has like a very low forward voltage drop. In other words, if we've got 3 volts coming in, if we were to use like a normal diode, then we'd like lose like a volt by the time we get to the other side of this diode. We'd only be seeing like 2 volts, which is not enough. But hopefully, if we use one of these, we can have like a really low forward voltage, like maybe 0.2 volts. So this can still easily run on 2.8 volts. Anyway, I don't know if any of this shit works, so we're gonna remake this right now on here. By the way, this is a standalone, like, offline version of something that's available on a website. Let me just find it and I'll link it in the chat. It's this. Oh, wait, why did that just paste the word circuit? What the fuck? What is happening? This. Cut. Paste. That's weird. Do I have a command for this? I feel like I should have a command for this. I don't know what it would be though. Let's make it a command called circuit sim. This is the circuit simulator I'm using. There we go. Now I can do this. Or I can. Anyway, let's go ahead and make a power source. Let's add a... where's it put in? Voltage source, 2 terminals. And I should set this... How do we... There we are, voltage. Let's say that it's... Yeah, let's say it's 5 volts. But I guess it doesn't have a regulator in here, does it? Active components. Building blocks? Oh my goodness, what's happening? Voltage controlled voltage source. Voltage controlled current source. Current controlled voltage. I don't think there's any of these. What I can probably just do is hang on a second. I haven't actually looked at all that stuff before. Well, we could just, I guess... I guess we could just ignore this part of the circuit and I'll just pretend that the voltage source is this instead. And I'll just disconnect this. And we'll see if things can keep running. In that case, we'll have it generate 3 volts. It auto-translated to Spanish when I clicked the link. Wow, what the hell is that an add-on that you have? Random question, but I came across a bag of chips from the UK called Walkers. Do you know the brand? Yeah, it's the brand of crisps. Yeah. I think it's called Lay's in America, right? It's one of these companies that decides to change its name depending on where it is. It's like the Walls ice cream brand. Have you seen this? There's like a huge grid of images of all their different logos in every different country. It's kind of funny. Walls, logos. Hold on.
Yuki Force.
What? Yuki Force? Yuki V Horse? What the? It's like this. This is smaller than I remember, but like it's called so many different things in different places. The same company. You say they're just better than Lay's? Really? I thought it was the same company. Interesting. Well, I guess they might make them differently anyway. Even if they're, you know, the same company. But anyway, let's just pretend that this voltage source is this section because this is all needed to get 3 volts. And then we'll have some loads. Let's just model this as a resistor, I guess. Not sure what a good value would be. I'm gonna try and lay this out in the same way as I've laid it out over here so it's easy to compare. Recipe might be slightly different depending on the region. Yeah, Burger King being Hungry Jack in Australia will always be amusing. Chicken Royale at Burger King, is this called over here? I don't think it's called that in America. Being called long chicken in Germany is really funny to me as well. Long chicken. That's my favorite thing to get from Burger King though. Pet the Digital Project. Thank you. Okay, so this is just gonna this load here is gonna be the LCD and the thingy amplifier. So what the fuck? How have I started adding this? Excuse me? So this is gonna continue down here. That was weird. What the fuck was that? Anyway. Hi Kaz, welcome.
Long chicken.
She said that perfectly. Hello, hi, welcome. Also the fact that Americans, like apparently in America, it's like Burger King is so much worse than McDonald's, but it's like, in my opinion, it's the complete opposite over here. Like the chips or fries are completely, they're just typically so soggy and basically just salt at the McDonald's over here. But is this running? One bad connection. Oh right, hang on, we gotta do this silly thing where we do this, right? Yeah. Whereas I don't know, the Burger King ones are actually like crunchy and not floppy and soggy. Anyway, the texture, size, and shape of the crisps is pretty different, and I like this. Oh, are you thinking of the Walker's Max ones? They have like this range called Max, which are like, they're like this kind of, and then I think the idea is that it catches the flavorings. I really love the paprika ones. I used to have that like pretty much for lunch when I was working, not from my bedroom. I used to have that as part of a meal deal thing. One time I had McDonald's in the UK, it was so salty. Right? I think I saw the word Supreme under the logo. I don't know what that means. Advertising, marketing, question mark? I don't know. Okay, let's make a diode. What kind of diodes do we have here? Passive component. Is it an active component? It's an active component apparently. Xenodiode and diode. I wonder if I add a diode? If it will let me set the forward voltage drop, maybe reverse voltage, breakdown voltage. Create new simple model question. Oh wait, it's even got, look at that, it's got presets for 2 Schottky diodes. That's pretty damn nice. Let's look up the datasheet for these two. See what their traits are. Hold on. I was gonna have to like enter values myself, but it's got 2 already. So 1N5711 datasheet. Uh, 70 volts. Oh wait, that's repetitive. Okay, I don't really care about that to be honest. 15 milliamps. Maximum continuous forward current. Oh wait, this actually doesn't matter at all because this diode is here. I was thinking this might pull up to, I don't know, like maybe I should like allow for this to pull up to like 10 milliamps, but the diode's here. The diode's not going to care about what this area is doing. This diode is only powering this, and this is going to be pulling like well less than 1 milliamp, so that's okay. But we probably should put some current limiting on this capacitor so that it's not going to try to like charge instantly at super as fast as possible and like a dead short, because that will probably upset this. It would also probably upset the regulator momentarily. Do I work in Fang? Hang on a second. Where are we? There we are. What is FAANG? I've heard of this before. I need to see what this is. No, I don't. The only thing I'm doing is streaming at the moment. And no, I've never worked in any... I've never done any of the stuff that I'm doing on stream for a job. I've basically just done... I don't really want to say, but it's nothing fancy. I've never done programming, never done electronics. Facebook, Apple, Amazon, Netflix, Google, I fucking wish. Holy shit. No. Unless you can count being paid by Twitch as working for Amazon. I see. Never seen you touching electronics till recently. How recently, I wonder? When you say that, do you mean the this project? The first one I did on stream was not even that one. The first one I did was this one. This one. God, I still haven't got a photo with this cleaned up. In fact, it's like so dusty. It's just like sitting in a pile of stuff at the moment, which is kind of sad. I can't believe, did I not record a video of this, like scrolling the long Yucca cross? I must have. I must have recorded that somewhere. But I don't have it saved on this computer. Do I have that on my Discord? It must be on my phone somewhere. I should find that. Oh, well, it's on stream, isn't it? Actually, there is a clip on my Twitch channel of it working. I just remembered. That's the first thing I did on stream, the first electronics thing. So that was near the end of 2023 that the boards were made, by the look of it. Looks like I was starting around the end of September, and then I had the finished thing like in early November. When did that happen? Because I've been a follower since last year. No worries. Okay, stop apologizing. It's perfectly fine. This was at the end of 2023. That was the first electronics project I did on stream. And the second one I did was this one, which ended up being a bust, unfortunately. That's not it. Where is it? Oh yeah. Man, the back of this one looked so much cooler. But it didn't work, so so who cares? So ended up remaking that. That was the most expensive mistake I've ever made in electronics. And then ended up looking like this since then. Which I'd say looks less cool, but actually fucking works, so that's what really counts. I guess this part looks kinda neat. And yeah, blah 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 blah, ended up looking like this. Well, this one if you prefer bright lights. Oh, right, now I put them all together into a thing. This is when I was sharing this with another VTuber, Oriana Aura, who I've been bringing up a lot recently. Before 2024? No worries, you take back the apology? Good. Getting better. I looked up stuff briefly. It looks like PepsiCo bought Lay's and Walkers, but they're actually distinct brands. Oh, interesting. Anyway, 15 milliamps. Okay, 15 milliamps. I would imagine that 1N5712 has like maybe higher stats, you know, like forward current or something. Out of curiosity, let's find out. Hold on. Where's again? 1N5712. 1N5712. Oh, I should probably be looking at the forward voltage drop. That's the most important thing for me. Why is a completely different datasheet showing up this time? Or website anyway. Maybe the datasheet's the same type. Nope, that's a completely different one. Holy crap. What the hell? What the? This isn't quite what I wanted. Hold on. This one? Documentation? Datasheets? Question mark? Is this the same datasheet? This is the same datasheet. Why is it totally different? This is so weird. Anyway, let's just see. Average rectified output current. This is completely different. What are you talking about? Forward continuous current. Well, I guess they word it differently, but like 15 milliamps, and then this one says average rectified output current for this one is 33 milliamps. Do we see a 33 anywhere in here? No, we don't. Do we see a 15 anywhere in here? Maximum forward voltage 1 amp at 15 milliamps. Whatever, let's just close this datasheet. I don't like it. It looks like an advert. Anyway, a level 4 component? Sure. Exactly. Yeah, you can think of it that way. Your stream's more interesting and informative for me than something fang, but also so hard. Because I'm not the program engineer. Well, I'm not going to be doing any programming tonight, probably. However, I should show some stuff that I programmed off stream. Because this is what was holding me back. Thank you very much for the Pats Pass. This is what was holding me back from working on this project, is that I wanted to finish or get into a usable state a side project.
Oh, agree. It is the Yuki. Very fluffy cat, deserving much pats.
Aww.
Fimshif, mimshif, munch.
Hi, welcome, welcome, welcome to Cabbage. Fmimshi, yes. Thank you for the pads. So I was working on a side project for this project, which is one to edit.
Oi, cheese.
Edit cheese, exactly. To get it off my face! Now I moved too quickly, my tracking broke. One to work on sound, edit sound for it in the specific format, and I needed to implement saving, and I basically already had. I just couldn't bring myself, I couldn't get the motivation to actually like make it proper. I finally did that last night. So now I just have to get motivation and into the right mental state to get back to programming this stuff. Anyway, forward voltage drop, that's what I really want to see. Where's your forward voltage drop? I guess it's going to be different depending on how much current you're applying. Ah, VUF. What the fuck? This isn't good. Oh, actually it's less for 1 milliamp. 0.41 volts?
Cheese removal technology.
I was expecting much less than that. Cheese removal technology. Wait, how did she say that?
Cheese removal technology.
Oh, she actually did say that. Thank you for the pants. I was hoping this would be closer to like 0.2 volts. This is quite a lot, but it looks like this goes down the less current you're pulling, which is nice. And this is definitely going to be pulling less than 1 milliamp. So this is definitely going to be pulling less than 1 milliamp. So I don't have any of these diodes, unfortunately. I have no Schottky diodes. I realized when I was looking at my components earlier. I have like some fast, like small signal diodes, and wait, are they Schottky? Hold on a second. I have one N4148. So I don't know if that would be classed as Schottky. Give a quick look. What's this? Just a small signal, fast switching. I wonder what its forward voltage drop is. Looking for VF. Why don't I just search for VF? Oh, it's right there. 1 volt, okay. But that's if you're putting 10 milliamps there. Anyway. TLDR, I don't have any Schottky diodes, but let's just pretend that I do, because I'm using this simulator after all. The impression that you can assemble a nuclear reactor or something like Iron Man at home. Okay, that is... That's an impression that's not grounded in reality, I'm afraid. My brain boils when I try to figure something out. Well, Don't worry. Thank you very much, though. Thank you for the kind words. It is really fun being able to make things yourself. It took a while to reach here, but it kind of was just through reading things and also being told a couple of things from another friend who was also really into electronics. Not that I really took it in much at the time, but looking back on it, I can see that they were trying to help. And they were saying things that if they'd said them nowadays, it would have been useful. My brain has now evolved to a state where I can take that in. But otherwise, it's basically through... I watched a lot of a YouTube channel called Big Clive, or bigclive.com, like all spelled out. DOTCOM is how it's named on YouTube. That's a Scottish guy who does a lot of videos where he takes things apart and reverse engineers the circuit and explains how it works. And just through watching a lot of them, you'll start hearing and seeing like a lot of same things, and you just kind of slowly start to pick up on like the rules, if you like, or conventions at the very least, that are done in circuits of certain kinds. And I'm like, okay, maybe I'll try doing some of this question mark. Anyway, yeah, I guess I've picked up a lot of stuff from his videos. I think he's done like actual videos that are designed to be explainy as well. Great Scott is another really good YouTube channel for that. But yeah, I tend to like Big Clives much more because they're much less produced. It's much more like a person just chatting. Anyway, let's go with 171 and 5711. Actually, what if I go on use simple model? I'm curious. Actually, no, fuck it. Let's just go on okay. Let's just put this in, and depending on how accurate the simulation is, we can actually see how much voltage will drop across this if we pull less than 1 milliamp. Let's try it. So the diode is here. We need a capacitor. This is passive, polarized. I don't know what value I need. Let's try 10 microfarads. Sure. It's probably gonna be more than that, honestly. I could see it being 100. I learned electrical engineering from watching a Scottish man blow up bulbs and incinerate plugs. Look, they're fun videos, alright? I also used to watch photonic induction when he existed. I think he's still alive, but he just doesn't make videos anymore. Or hasn't for a long time. It's not to say he won't again. Anyway, so let me set up some graphs. Let's set up a graph across this. Oh, hang on, we need one more thing. Let's put a resistor. So this is going to be the load for the microcontroller. Okay, so let's do a calculation. So I want to simulate that this is drawing about... let's say 1 milliamp for like super... No, it's going to be less than 1 milliamp. Wait, when I write to EEPROM, does the power consumption of this go up? I think it might. But I guess it doesn't matter because the entire time that this is running, this is not going to be pulling high power. And during the time when this is running, it's that's when this is going to be charging. When this turns off, none of this stuff is happening. And this is like nothing's coming through here either. So when this goes to high current, it doesn't matter. It's not actually going to be pulling high current through this. So the fact that maybe the voltage drop goes higher and less voltage gets through here is irrelevant because there is nothing coming from here because the battery's been pulled out. So yeah, the current might go up a bit when this is writing to its EEPROM. But we'll pretend that we're drawing like, let's say 300 milliamps? Microamps, not milliamps. Okay, so what do I need? What resistor do I need to make 300 microamps flow if we've got 300 volts here? I mean 3 volts. Okay. So, so V equals I over R, right? So it's like V is I over R. How is this drawn again? Is it? I think it's like this, right? Isn't it like this? I actually can't remember. Let me have a look. See, this is where it becomes painfully obvious that I haven't actually learned this stuff correctly. VIR triangle. Okay, yeah. I don't know which way I drew it, but I drew it wrongly. Anyway, it's actually this. V over IR. It's not V equals I over R, it's V equals IR. I said over when I shouldn't have said over. Oh well. What could possibly have gone wrong? Anyway, so we want 300 microamps, so, and we have 3 volts. So 3 divided by, and we want like 300 microamps, so 3 over 300 divided by 1000, that's milliamps, and divided by 1000 again, that's micro... Wait, hang on, what's happening? I haven't even closed the bracket yet. Why is it calculating things? I'm getting confused here. Okay, let's calculate this fairly fast. So it's 3 over 1000 over 1000. I don't trust what this calculator is doing when I just don't copy the result and start a new calculation. Anyway, and this is running at 3 volts. So we need a 1 mega ohm resistor. Holy crap. In order to allow like 300 microohms in. Okay, 1 M instead. And we'll branch that down to there. Aussie 50? Yeah, Aussie 50. Yeah, rest in peace, Aussie 50. He was fun. I have an idea. Instead of checking, but he didn't die because of the stuff he was doing. I think it was cancer, right? I have an idea. Instead of checking the availability of battery by ADC, you can set up an interrupt on pin that will be triggered when it gets from high to low. Yes, that's what I'll use for the sudden detection of battery being disconnected. But every now and then I also want to be monitoring this, like maybe every minute or so, just to see if it's dropped too low. But yes, I definitely want to use an interrupt so that I can immediately act when the power gets pulled. Also, the STM32 has some very nice pins on it. It has some pins that are tolerant of 5. I think it's like I'm fairly sure that it has pins that are 5 volt tolerant. It's not all of the pins, but some of them are tolerant of 5 volts no matter what the supply voltage is. Because normally pins don't want you like putting in a voltage that's much above the supply voltage, but this has some nice ones. So we could probably just I don't know. A fully charged battery might be too high though. We might still have to do something to divide it down. You're not dumb. I hadn't actually mentioned that at all in here. You're going based on this, and yes, what I just explained was a thought I had just before starting stream today, so I didn't even think about it before either. Okay, so you can see this is passing a tiny bit. Let's set up some graphs. We want to graph this. So how do you do this? View and scope. What are you measuring? Oh, there we are. 3 micron. Okay, I've gone slightly too far. Looks like it's more 10k. But this is what we actually want. Yep, there we are. Okay, so 300 microamps. How did I mess that up? 300 divided by 1000 divided by 1000. That is micro, right? How did I type that wrongly? What is this voltage as well? 2.646. Okay, so yeah, it's a bit lower. 2.6 volts. I mean, that's enough. That's enough for this to run, I think. I think. Anyway. Alright, we should also, let me just put a resistor across here as well. This is going to be very cramped. I should probably make this wider. Can I do something like this and just... oh my god, I almost can. It almost worked. Okay, let's put a resistor here. Huh? Wait, why is that separate to passive components? Is the resistor not a passive component? Anyway. This is annoyingly not centerable. Ah! Blop, 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 and blop. Okay, so we want to be able to pull no more than... was it 15 milliamps, I think, was like the peak? This is forward continuous current as well. This should just be like a one-off peak right at the very beginning, so it actually might not even be that bad.
Blop, blop, blop.
Burlop. Burlop. Okay, so if we were to limit it to 15 milliamps, then we would... slash me. Oh my goodness, I've got too much stuff running. Hold on. Hold on, there's too much stuff in the taskbar. I can't fit in a calculator anymore. What can I close? This. And this. And this. Okay. Made some space in my taskbar. You know, Maysaka has closed some tabs on Firefox as a redeem. I need to close some things to make my taskbar have some more space as a redeem. Anyway, V equals I over R. So if you cover... wait! Was I being really... I feel like I was being really stupid. Anyway, if we pretend that this is 3 volts, even though it's a bit less, and we want to limit it to 15 milliamps, and 15 over 1000, and 3 volts divided by that would be 200 ohms. What a nice number. Hi, Incom Polo. Hi, welcome. Hoi. Okay. So we're measuring the volt. Which one's the thingy? That's the voltage. That's the current. So, if the power were to be cut right now, this. Oh, hang on. Let's monitor this one as well. I wanna monitor this so that we can see that. This should stop working immediately, and this should gradually stop working. So let's add that one as well. Okay. Why are we saying negative here? What the... does this have, like... does the resistor have a flipping polarity? Do I need to turn it around the other way to avoid weirdness? Apparently! Didn't know resistors have polarity in this program? I guess it makes sense for... telling which directions things flowing. Anyway, this is currently passing 3 milliamps. So actually I'm going to reduce this resistance so that it goes even higher, because we could get higher than that. Okay, now we're passing 6 milliamps. Honestly, it could be worse than that. Let's make an even more worst case. 13. Okay, now we're over what it's likely to be, but I guess 300, right? That would make it 10 milliamps. Okay. Diodema. Yeah, she's just allowing it one way. She's like what do you call it? What's the word? Directing the traffic. That's not a word. But anyway. Okay, so if the power were to be removed now, this should immediately drop, and hopefully this will gradually drop, and I don't know how long this will take to drop. Ah! Where am I derpy? How far apart are these lines? 0.43, 0.44, 0.45. So these are... Why? Why am I being sprayed? Hi, Rain. Welcome. So these horizontal lines...
0.01 seconds apart, which is very evil. But hi. So the these are 10 milliseconds apart. So let's pull out the battery and see what happens. Boop. Oh my god, look at that. It actually... Oh, you can't see shit because I'm in the way. Yeah.
Jeez.
Watch this. Boop. That immediately turns off, and this gradually drains away. Let me stop this. Wow. I can't believe how well that works. Mind you, this is still pulling only 300 microamps, and it might be higher. I'm guessing it won't really make much of a difference if I pull that out.
Let's try again. I guess not. Also, hi David, welcome. Wide and evil, yeah. I'm evil, but I don't intend to be. It's just derpy. Oh, I could have done this to make it more visible. Why didn't I do that? Will you have any issues during startup with a slow ramp up? I shouldn't do. The STM32 has like a built-in thingy where it just requires the voltage to be above a threshold before it starts. And this voltage is like higher than the brownout voltage, so there's like a hysteresis so that it won't oscillate. So it should be okay. So it has that built into it already, thankfully. Hi, Yuke, it's late for you? It is. It is. It is. The RC circuit will fall off slowly, but will also come up slowly. Yeah, it comes up less slowly though, because we've got like a 200. Here, watch. Wait, how do I? Wait, that's not the one. Yeah. Okay, let me change this. Hold on. 10 milliseconds. 50 milliseconds. Sure. I'll do the same for this one. Like when I connect it charges very quickly, but when I disconnect it, it's more slow. But this thing can't keep running below some voltage. I don't remember what it is. Technically, I'm pretty sure it can run on 1.8 volts, but it has to, you have to set it up to do that. Basically, put the CPU into a mode where it uses less current. So, yeah, I don't know. So it looks like we get like... And this is just with a 10 microfarad capacitor as well. This is not much. If we were to make this 100... boop. Kind of surprised at how quickly it charges still. Beep. This is a long time. Okay. Maybe 100 is excessive. Maybe 100 is excessive. We could probably go on for a few seconds with 100. Maybe that's more than we need. 47. Probably be okay. Microamps? But now these circuits are not evil. It's for power along nuke. The long nuke is not evil. She doesn't know the definition of evil, but she doesn't know the definition of many things, so it's not really a great argument. Anyway, once this thing is done, like I said, we probably want to make it try to discharge its own capacitor as quickly as it can in order to make the brownout circuitry kick in as quickly as possible, so that when we reconnect the battery it starts fresh and not in the middle of it, or not in the... Okay, so when this gets triggered, when it detects a low voltage, what's actually going to happen is it's going to write the state to EEPROM and then go into like an infinite loop, basically end execution, if you like, go into a loop that it can never come out of because it's done all that it can do. And then when the power comes back on, starting code from a fresh memory, if you like, it's going to, as part of the startup process, look in its EEPROM and try to resume from stuff in there. And I said try to resume. I wonder if there needs to be some way of error checking this, but whatever. Yeah, so in order to make it start afresh and not continue in its infinite loop of nothingness, when you connect a new battery, we should try to discharge its capacitor.
Infinite loop. Like the long Yuki eating her own tail.
Yeah, like this. Like that. She can't quite catch it though. The long Yuki in her own tail. Okay, so when this is done, we would want to be able to discharge this. So I guess we just want a transistor that can switch across this, probably with a bit of current limiting, right? We could just do something silly like set up the CPU to be like a really high clock speed. So that it pulls a few milliamps. But frankly, a few milliamps is probably still going to be kind of slow to discharge. Well, let's see, a few milliamps. So this is 10 milliamps. If this were pulling 10 milliamps, how long would it take?
I would like to interject for a moment, but what you're referring to as Yuke is in fact Long Yuke, or as I've recently taken to call her, Long plus Yuke.
Long plus Yuke. Okay, that actually discharges pretty damn quickly. Long plus Yuke. Okay. Right, I think this might work. But let's just put a transistor in here and see how much current would actually be needing to put through the transistor to discharge it. I have some little transistors. I forget the numbers of them. Okay. Where are they? What the hell? There we are. BC337 and BC327, which are okay with up to 600 milliamps if I remember rightly. So let's build up a little circuit. This is probably going to start getting cramped again. Let's just add, I guess, an NPN transistor. Where's a normal one? There it is. And why does it only show BC when it's this way around and not when it's this way around? It's a bit strange. Anyway, so we are going to, what way do I want this arranged? I guess I want it flipped around for easiest fitting in. So with no current limiting, no, that's silly. Let's add some current limiting. I don't know how much we need though. What if I just add like, I don't know, 10 ohms or something. I'm getting bothered by the fact that I can't center this again. Ah! My OCD. Okay, we won't try to center it at all. So to short this to over there, can I just go? Oh, how do I keep doing that? How does that keep happening? It's the second time it's happened already. I'm gonna widen this entire area. Oh, sure. This simulator is so flipping nice. It's just, I wouldn't like 100% trust it. I'd still want to like put it on a breadboard and stuff and like do my own measurements, but like just for playing around and getting an idea of how stuff might work, it's so nice to just be able to do this. Now let's add a resistor to there. Let's say that it's 10 ohms. Okay, so now in order to make this thing turn on, we would connect this to here. And when I connect this, so this, like the power supply here, let's just do it like this. So when I do this, it's going to discharge this basically. And probably go into like a... Yeah, let's just see what happens. Boop. Interesting. Oh wait, I should be doing this through a resistor as well, to not destroy the transistor. Thankfully, it's not a real transistor. So 1K will probably be okay. So at this point, let's put a measurement across the capacitor as well. Like a scope. Oh, why does the scope not close it? Scope. Okay, yeah, so it's pretty much discharged at that point. 185 millivolts. But this is still running because... What's going across this? 12 milliamps is going across this. So I guess its voltage has dropped. 2.4 volts? I don't know what it was before. Oh, you can see it going up now. That's pretty cool, isn't it? So as soon as this turns on... Pew! Look at that. And the current there, what was that peak? About 233... Oh no, 32 milliamps. Okay. I mean, that's fine. That's not a crazy amount. And it discharged pretty quickly as well. How long would that take to discharge? So this is what... 50 milliseconds? So it took... Wait, what, hang on, what are we measuring here? We're measuring the voltage across the capacitor. Oh wait, this is oh my goodness. Wait, you can zoom in on here? I just realized you can zoom in on these. Oh my goodness, that's amazing. I just accidentally discovered that. That like discharged in like a really tiny fraction of a second from 4.973 to 4.977. So in like 4 milliseconds it discharged this capacitor. That's super nice. And it only pulled like 38 milliamps to do it. This seems fine. This seems like, wow, this would be super viable to do. And it seems like it'd work really well. Hi Clonk, welcome, welcome. Let me save this. Save as... what should I call this? Let's call this, battery... What do I call this? Battery... I'm going to type battery disconnect... Backup. I don't know. Voltage would always try to find the easiest way to follow. Yeah. Oh, right, true. So it would keep flowing here. One part I forgot to mention is that the battery would be disconnected at this point. So let's try and do what it would actually do. Let's slow down the whole simulation so that it's slow enough that I can, you know, react in time. So if the battery goes out, bam, this is now writing. Hopefully the interrupt is fired immediately and it's going to be like writing the stuff to EEPROM as its voltage is gradually dropping. I don't know how long this is going to take, so we'll let some time pass. Blah, blah, blah. And then when it's done, it's going to do this. Pew! And discharge this capacitor. And at this point, the voltage across this is half a volt, so well below its minimum, so... Mind you, this transistor is not going to stay on once the voltage has dropped too low. Because when the voltage drops too low, I would expect that all the GPIO pins go low. I mean, you know, there's going to be no voltage to make them be high, so this is not going to fully discharge. At some point while it's discharging, this thing will like crash basically, and the GPIO pins will be unable to sustain a high enough voltage to make this transistor stay on, even if this didn't crash. So this would actually probably gradually turn off. It'd be like someone's dimming this, so we wouldn't fully discharge this capacitor, but hopefully we discharge it enough I mean, what all we're trying to do is discharge it enough that it triggers the brownout detection in the microcontroller here. This thing is the microcontroller. So as long as that happens and it crashes, and by crashes I mean like gets turned off in a controlled way thanks to the brownout detection that's built in, then it'll be fine. And when the battery gets reconnected, it'll start from like this state. Boop. And it should, you know, start from the beginning. This is taking a little while to charge up, actually. Oh, mind you, when I look at the scale of the seconds, it's like 5.5 seconds up to 5.55 seconds. So I think it's fast enough. Do you show the circuit with this system? 200 ohms and 10. The 200 ohms here is just so that the capacitor doesn't try and pull a huge amount of current through this diode when the circuit first starts. Even though it's for such a short amount of time, it might be okay. I don't want to risk it. And yes, it discharges this capacitor through this 10 ohm resistor. That's my plan. That's my plan. Oh yeah, right. It makes no sense to do that while the battery is still plugged in. Boop. Pew. I love that. But we can see the speeds of the dots. Let me turn up the speed of the dots. Obviously this part's now a mess. This really high current part is a mess, but let's ignore that. This is where the interesting stuff is happening. I just wanted to build this part so that I can make sure that this diode would prevent this capacitor from powering this high current part, so it only gets used for the microcontroller. Okay, let's turn up the speed a bit more. Oh, not that much. Sure. I just want to see what it looks like when I go. Boop! Oh wow, I forgot to do the thing where I disconnect the battery. Boop! And then when this comes back in, a lot of current is being used here to charge this capacitor. And then that's about it. I mean, this looks like it would work. I don't know if it actually would. The top-down schematic is messing with my head. Top-down schematic? Oh, sorry. I was just trying to make it the same to, the same layout as the thing I scribbled on Paint. Remember? Oh, sorry. Yeah, I've already read that. Yeah, good evening. I don't know if I said good evening, Klung. Probably said hi. Alright, I'm pretty happy with this. I'm pretty happy with this. Kind of want to monitor what happens to the diode out of curiosity. Ah, we can see the voltage that's dropping across it. Wait, that's something that I was interested in earlier. Hold on. So while this is pulling 300 microamps, this particular diode, which remember, this is like actually set up to be a real diode, like a 1N5711, not just a generic thing. Ah!
Jeez.
Why? Its voltage drop is apparently 3.5 volts. Down there it says 354 millivolts. It's still a lot more than I want. It's still, well, not a lot more than I want, it's still a bit more than I want. So I'll probably look into different Schottky diodes. Shall we swap this out for the 1N5712? I wonder if that has better stats. This one drops... Oh, look at that. This one drops 337 millivolts. So what did this just do? This just... The capacitor just charged a bit more, which is interesting. So I guess this is because this has a lower voltage drop? 337 is that now? And if I switch back, yeah, the capacitor now has to be discharging to provide some of this. Yeah, okay, so this one, 5712 has a slightly lower forward voltage apparently. Close the Xeno for a moment. Understandable. Not this time though. What options do I get when I click this button? Forward voltage, saturation current. I don't even know. I this is not even a thing that I'm aware of. Current at above voltage. Wanna breakdown voltage 70. So this is the voltage that is gonna unintentionally let stuff through at if the voltage on this side gets too high. But we don't really care about that because the voltage on this side is only ever going to be as high. Well, this side is being charged up by this, and this is 3 volts. So this is never going to be above 3 volts. I mean, it's going to be a bit less than 3 volts. So I don't even care. If I can find, like, what I really want is a Schottky diode with as low a forward voltage drop as possible. And I was reading about Schottky diodes earlier, and it turns out that the lower the forward voltage drop is, also the lower the reverse breakdown voltage is. So, but because this is only going to be like less than 3 volts, I'm willing to pay the price. Like, I don't care if this thing breaks down at 10 volts. That's like still like 3 times as high a voltage as it's ever going to see. Like this here, the microcontroller, this microcontroller is going to die if the voltage is ever like as high as 10 volts. So like if the voltage gets that high, we've got bigger problems than the diode. The entire damn microcontroller is going to be dead. I mean, this will be dead by the time it reaches 5 volts, so... You could use an ideal diode like NID 5100. Ideal diode? An ideal diode? Also, High Hobgoblin. I never said High Hobgoblin. Is that like an actual one, or is it like a theoretical one? Also, I'm kind of curious. Let me just go to LCSC. I haven't been to LCSC for a while. See if we can search for things. Yoink. Well, this is probably where I'm gonna be getting the components from. So if we search for, where will this be? Products. Question mark. This is the products. Oh, there we are. Diodes. I don't really need it as a bridge. The single diodes, I guess. Let's try single diodes. It's an IC that switches a MOSFET to act like a diode. What the fuck? That sounds interesting. It's gonna have to pull like really low current though. Like really, 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 really like just a couple of microamps for that to be worth it for me. That sounds very interesting though. Let me look that up. You have piqued my curiosity. I didn't even know such a thing existed. What a cool idea. Give me that datasheet. Low quiescent current. Okay, one thing I've learned from looking at this is that manufacturers have vastly different opinions about what low current is. But let's see what this is. You tell me when you're quiescent. Oh, there you are. Oh, nice. Okay. That's very low current. Nice. That's sub 1 microamp. Oof. Okay, so it's definitely on the tables. That's a possibility. Yeah. Wow, this is fascinating. Okay. So drive this low to enable a device, drive high to disable. So it's going to be enabled the entire time, I'd assume. Oh, hang on, what are the voltages? 1.2 to 5.5. That also seems really good. Fairly sure 1.2 volts is below the minimum possible brownout voltage for the microcontrollers, so... let me get the datasheet up for the microcontroller. Boop. Oh, I'm on the right page. What the hell? Or close to it anyway. Standard operating voltage. Yeah, 1.65 minimum if you're not using the burnout detector. Okay, so that should be fine. That's above. Whoa! Hi! Welcome, welcome! Hi, Ariana!
Cheers.
Why cheese? Welcome, welcome. Stop!
Cheese.
Stop!
Lactose
Hello.
dairy
Hi,
product.
Alex. Welcome, welcome. What were you up to today? What were you up to? What is your new project since doing the tense thingy? I was on your stream the other day, but the VOD isn't uploaded. So, since I have no memory, I don't remember what it was that you were doing. Anyway, let's have a look. No, let me do the shout out! Oh my god. Okay, let me do a shout out. Creating an artificial heart. Oh yeah, right! That's what you were doing on the previous stream. You're still working on it again today? Pat. Look at this. If you're interested in like electronics stuff and fun little like actual real physical projects and like projects where stuff actually gets done instead of it just being theoretical, I mean it eventually happens with mine, but it takes a long time, then please check out Ariana.
I insist. Oriana didn't give a raid message. No worries. Welcome in, Tai. Hi. Welcome in, Scowly Ghoul as well. Hello there. Okay, I need to pat Ori, but... I won't be able to do it until Derpy wears off, because this prevents how close my hand can get, I'm sorry. I'll put it on your tab, and, I'll do it when I can. Stop!
I swear. Let me show you what I'm up to. Also, hi, welcome. I'm the weird cat who's trying to make a circuit for protecting the. Oh, not really protecting, but I'll explain in one sec. As soon as this derpy wears off, I'm gonna be giving headpads, so you better believe it. Oh, Gouda! Oh my god, are you gonna get the parts for this stuff? Yeah, well, eventually. I'm just sort of simulating on here at the moment because I mean, I wanted to see if this idea held any water at all. But yeah, I should. And actually right now I'm starting to look at datasheets for potential parts as recommended by Hobgoblin 612. Anyway, it's worn off, so let me give headpads. Pats for the ore. Cat evolved into an entity. It happens occasionally. It happens occasionally. That's cool. I'm gonna have to check out that. The VOD if you make it live. Beware that they can supply any current on the IO pins may feed into the IO pins. That's an interesting thing. Aw, thank you, Meridian. Also, hi, Meridian. I might already send that. I have a bad memory. So, let me just show this. Zip. Yeah, zip. So I'm wanting to make a little digital pet style thing, like a Tamagotchi. This was a test for like an animation the test of drawing her from individual parts and stuff. And this is a test of the snow and rain rendering, because I'm wanting to make a little weather system-y kind of thing built into this. Nothing like scope creep. And there's also sound. This was just a random piece of sound from some other project, but she'll have a voice similar to this probably. Also, this is the visualization of like the speech decoder. I think there's actually a mistake in how it's drawing one of these bars. I'm not sure which one. Ignore the what sounds like the cracking voice. It wasn't able to track the pitch super well in the encoder for the format of speech wasn't able to track the pitch in the original sound very well, which is why I was making a whole separate project, which I finally finished, which is now finally coming back to this, but the separate project is one for editing the sound. You know what? I might as well show that off right now. Let's show that off right now. Right now! Scope creep. This will take a while, so let me... okay. Now with the STM and the heart Oriana just made, it will be a fully functional pet. Oh no, we'll have to make the heart pump faster when she's running away from the rain to get to shelter. Make mistake? Oh, I see what you mean. Okay, let's run this. This thingy was made in VB.net. But the actual project for this is in C. Anyway, I'm waiting for this thingy to load. It's taking a long time. Oh, it's already running in the background. Hold on, where is it? No, it's not. Oh my god. Why is Visual Studio so insanely slow? My computer's dying! Oh, here it is. Anyway. So, you can like load a sound that's already being converted by a separate program. Mine doesn't do the converting yet. But if you load a sound such as this, then it appears here. You can play it. You can also go into this mode, where you can hear what each separate frame sounds like. And this here is the pitch. Eventually I want to make this be able to visualize different things. This is all not a great layout at the moment, but it's just starting to get functional, which is what I really like. So instead of this, this, you could draw a different thing like this, and now it sounds like this. And then there are also these things on the side here. These are values that affect how the sound is filtered to make like mouth sounds, mouth shape sounds. So, and you can change those as well. But it's incredibly difficult to predict the effect it'll have, but you can do it anyway. For example, it's possible to make very nasty sounds. And when you're done making your masterpiece, you can now save it as a text-based file or binary. Demonmonster.txt. So this is... Oh wait, I gotta find the folder, hold on. VS projects, this one, and here it is. So then you'd be able to just paste this into a project that uses the Talkie, the Arduino Talkie library, which is a software emulation of the chip that this is for. Wait. Wait, hang on. What's the command? What is the command? What is the command? Where's my... Hold on. I forgot what the command was. Wait. I can just type this. It's none of those. What the hell? Where did I put it? Hold on a second. What's going on? No, I don't want a Unity crash handler. What the fuck? Oh my god, where is it? Is it just project? Oh, there it is. Okay, it's just project. Okay, sure. It's that chip. So this is a chip made by Texas Instruments. By the way, thank you very much for the follow, Flat Gainful and Surly Scowly Ghoul and Ty. For some reason, my follow notifications are broken. So let me just restart my streaming setup. Hold on. I'm gonna disappear into the void. That was the sound of me freezing. Oh my god, did the music even restarted? I'll change track at that moment. Okay. Shush. Okay, it might work now. Who knows? Anyway. There's only one frame that's demonic and it goes through it so quickly you can barely hear it. That one. Anyway. Stuff. I also tried to make some... Wait, actually these are not... So this is like really bad quality right now. This is me saying, have you ever considered Nyan? And if we wanted to clean this up, we could... What? Oh, hang on a second, my logo thing. Yes, okay, follow notifications are working now. Thank you very much for the follow, Jet Pinky. So, thank you for the pants, Shika, as well. So if we wanted to clean this up, we could... For a start, we have some weird sounds here, so we can pull this to be just noise-based instead. Like that. Maybe it's a bit too loud. What's the best way to do this? Would it be better to have this as noise-based? It might be. It's probably gonna be very loud though. Okay, so have you ever... Oh wait, I forgot that I implemented proper scrolling so I can just use the scroll wheel now. For the longest time you couldn't use the scroll wheel, but thank god you can now. Okay, so this is a real messy one. This would actually take a bunch of cleaning up. Let's just...
For the longest time. Woo-hoo.
For the longest time, whoa, what is that? In my encoder, I was misspelled TMS 5220 as TMS 55. I didn't even notice the difference at first until I read that entire message from this. Wow. So this is meant to be... These are meant to be noise, so we can... Sure. Should we make this noise as well, so we get a little blast of noise for the considered sound? Oh, that is quiet actually. Can we bump this volume up a bit? Oops. I actually think it sounds better when it's not. Sure. That goes to a bit of a low pitch there. Okay, so this is far too... Oh, listen to these amazing LPC artifacts. This is such a characteristically circuit bend sound of this. These fun sounds. If you've ever seen like a circuit bend Furby or something. The original Furbies also used LPC for their speech, and it has a very characteristic noise. Try using the audio from the clip I sent. That would involve me converting it first, which is a bit of a long, annoying process, and I don't want to do that right now, I'm sorry. So we don't want this noise. We could just set the volume to 0 completely. We can just like have this start high and then fade out quickly. Sure. and the nyan at the beginning. So when I was recording this, I was like whispering kind of like I am now. By the way, the reason I'm whispering is because the time is 2 a.m. almost, and there are people trying to sleep in the room behind me, so... Your needs to be... So they are silent already. So when I started saying nyan, it was like... nyan at first. So it started putting down noise, but we don't want that. So this is really where the sound begins. So we could really just keep those silent as well. And it just starts like this. Oh, that one will go as well. Sure. Could have it fade in more even. And again, it's happening here as the voice is fading off. It's getting really uncertain about pitch and just going into noise as well. So we don't need this one at all, really. Oh, I guess you could have it, in fact. But the pitch here is getting silly, so let's just draw that like that. And now, the fully clean sound sounds like this instead. Which is a hell of a lot less messy than it was at the beginning. I might want to change up the volumes of some of these noise bursts as well if I want it to actually sound good. But yeah, you can do stuff like that. Let me now save this actually as ever considered cleaned. And yeah, there you go. Live demonstration of the way that you can use it to clean up sounds. And so I wanted to make a program that would let me do that. And so I did. Thank you for the posture check. Drag and drop converter, maybe at some point. You have to go for around 30 minutes? No. Oh, Crystal! Hi, Chris! Welcome. I didn't even see you there. Hello, hi. Oh wait, that was from a long time ago. Never mind, that was from a long time ago. I just saw the Sheikah's thingy and I thought it was a response to a recent one. Oh my god, hold on. I was fiddling with the springs of my mic stand and I got them stuck in between each other. Alright, thank you for the push check and hydration. Let me do that as well. I'm out of tea, so I'll just drink from the bottle now. And yeah, this circuit in particular, I do that sometimes as well. On Discord especially, because Discord remembers the reply thing per channel. And sometimes I'll come back to like a server where I was going to reply and I never typed reply, but I clicked the reply and then I'll type a new message and it's like, you are replying to this person. So this little circuit here is to allow the microcontroller, to keep running when the battery gets pulled, just for long enough for it to write a to save itself, to save the state. So yeah. So what this would do is once this is popped out, there's the battery up here, and this here is representing the microcontroller. So when we pop the battery out, this keeps running for a while. This stops immediately. This represents the high current stuff, like the LCD and the sound. And once this is finished running, it will turn on this transistor and boop, discharge this capacitor. It won't fully discharge it because it'll like brown out because of too low a voltage once it goes too low. But by that point, it's fine. That's the entire point of this, is to discharge it. Anyway, someone asked a question earlier, and that was actually kind of important. I think. What connections will you have from the STM32 to the LCD and diode and other things? Sorry, hang on a second. What connections will you have from the STM32 to the LCD and other things that are before the diode? Be aware that if they can supply any current on their I/O pins, they may backfeed power to the I/O pins of the STM32. I mean, this stuff... Oh, you mean like at this moment when it first powers up? Yeah, that's true, right? They'll get their power before this turns on. Yeah, that's true. that shouldn't be a problem if I connect them on the 5-volt tolerant pins, because the 5-volt tolerant pins on this can accept any, a voltage quite a bit higher than supply, so that would be okay. But what would be a problem is if this keeps on outputting a signal over to this here. If the STM32 keeps on giving signals to the LCD, for example, thank you, Stu. I'll do that very soon. How fast that's the cat? Kind of well, thank you. What would be a problem is if this keeps, if the STM32 keeps sending stuff to the LCD, when the LCD is not receiving power, that I've killed an LCD by doing that by mistake. So, well, not quite. I think I was running it at 3 volts and I was giving it 5-volt signals. So that's not even as bad as the situation where this is running at 0 volts and giving it signals. So it would be even worse if that were to happen. So really? Yeah, really? Maybe? Well, there is going to be a tiny capacitor here, like really, really tiny, just in order to keep the regulator working. So, maybe that'll keep power to this for just long enough that this can respond to the interrupt. And when it responds to the interrupt, I guess the very first thing you should do is turn off all the outputs to these things. That's probably what it should do. To avoid damaging these. I guess we could add a tiny capacitor here. Bear in mind, this here is representing the voltage regulator. So this, the actual battery will be above it. And we're going to be, like, reacting based on the actual battery's voltage. So I'm dropping to 0 rather than this dropping to 0. So this might be able to keep outputting for like a tiny, fraction of a millisecond longer due to this. I guess we could put just a small capacitor here. Let's just put a small capacitor here. Just enough to keep it running for a small amount of time. I think that's actually a really good idea. I will go and save the kidneys in just a moment as well. I do actually need to, so that's good. Thank you. Thank you for doing that. LCD dies if you send voltage on IO pins when there's no voltage. Yes. Higher than the... If you send anything on an IO that's higher than the supply. And obviously, if the supply is 0, then anything is higher than the supply. Okay, so if we were now to take this out. Pew. Yeah. I wonder how long I love the way this looks like it's slowing down. It really is just like a wheel with momentum, But yeah, the cat fell stands not too badly, thank you. I'm really happy that I'm trying this out, and thank you so much, Hobgoblin, for mentioning that as well. That's actually a really good point. Okay. Let me just measure this as well. Let me just add one more scope and then I'll go and save the kidneys. Okay, go to the toilet. Let me just, let's measure the voltage across, here, why not? Boop. So we can make power. This charges up. I might want to put some current limiting on this, just a tiny bit to avoid upsetting the regulator. Okay, so everything's running now. And when this gets turned off, how long does this keep powering the high current part? Bear in mind, the high current part. It might not be that high current, but just in the worst case, it might be high current, so... Okay, so that kept going for... That's a really, really short amount of time. That's like just a couple of milliseconds. Why are you intentionally discharging the hold-up cap with a transistor? Hi, Flaginful. Because when the battery gets disconnected... I swear I will go and save the kidney soon, Stu, I promise I will. When the battery gets disconnected, we're gonna detect that. This here, by the way, is a placeholder for the microcontroller. This. So when the battery voltage drops to 0. Oh my god. Okay, I'll be right back. I'm gonna go and save the kidneys. And then when I come back, I'll be able to explain the thing. Pew. Onion, I have returned. Hi, I'm back. Kidneys have been saved. I came back right as the music was getting to the climax. I'm sorry. I don't know if Flat Gainful is still here. If you are, I'll explain it. If not, I won't because I've already explained it. Ah, you are? Okay, nice. So, thank you very much for sticking around. So, the microcontroller is gonna be using the voltage from this battery as an interrupt when it goes low, because someone yoinks the battery out. It's going to start writing backup, like saving the state of the world to EEPROM, which should only take a few seconds. But I'm not sure. I should check the datasheet actually. I've never used EEPROM on this microcontroller, so I'm not sure how long it actually takes or how much current it takes. But anyway, once it's done that, we want the microcontroller to basically turn off. So basically, we want the brownout detection circuitry inside it, which is built in, to like pull it into a reset state and hold it there until a new battery is put in and the voltage goes up. By the way, this is specifically for when the battery's been removed. It's not like the voltage has gradually gone too low. We'll be monitoring that in like a more active way, like every minute or so. So in order to use up this, once we've done our job of saving the state, I want to short the capacitor basically to discharge it, because otherwise what could happen if we don't do that is, like, if someone takes the battery out and then replaces it with a new one, and this capacitor held onto its charge, then we, after saving the world state, will have gone into like an infinite loop, just because we have nothing left to do. And then when the new battery comes in, we'll still be in that infinite loop, and we'll get stuck in that infinite loop, and we'll never come out. So we want, when a new battery is put in, to be starting from like a fresh state, rather than being in the middle of an infinite loop. We want to do like this proper startup code and stuff. So I'm just doing this to hopefully, you know, act as if the battery had been out for a long time already, even if it takes like just a few seconds. Because thank you very much for the pads. Because this is such like low power consumption microcontroller, there's a chance that it could keep running for long enough. Not sure how long though. I'm gonna look up in the datasheet. Thank you for the pat, Stu. I can't remember if I said thank you. I said thank you, but I'm not sure if I said specifically to you. So yeah, thanks. You can put down switches if you want, instead of dragging elements to disconnect them. That's true, I could. I forgot about that. I want to see, maybe you can just have the BTT pull down the reset line to reset states. Yes, I probably could, but at the moment that I do that, it's gonna reset and start running again. It's not gonna stay reset because, well, it's gonna reset, so the GPIO is gonna reset and it'll start running. And I guess possibly re-trigger the... It depends if the interrupt... Yeah, I guess it wouldn't, because the interrupt is probably only going to trigger on the falling edge. It's not going to like trigger over and over and over again. It's looking for the change from high to low, so it probably wouldn't re-trigger. It would be weird though, having it running when you can't see anything. Oh right, no, hang on, right, this is going back to what someone brought up earlier, which is that you want to make sure that you're not outputting anything like IO to this area, this like the LCD or the amp. I don't think the amp would have a problem, but the LCD would. Oh, the amp might. I don't know. But otherwise these could get damaged if you're giving them IO, but they're not getting any supply voltage. So kind of the very first thing I want the interrupt to do is turn off all of its IO. And then save the state. What the hell, how have I managed to do that? Hope you're doing well. This circuit program looks nice. Just the amount of moving electrons I need to understand what's happening. Yes. Oh, I actually did make a command. Ta-da! I did. Just today I did. Okay, so I want to see... Come on! I want to see how long it takes to write to the EEPROM, and I have the wrong sheet open. Where's the other one? Reference manual, it's probably in this one. Let's try both. EEPROM. Oh, it's got 2 kilobytes of EEPROM actually, it's more than I thought. I thought it had 1K. I want to try to do, because EEPROM has a limited number of write cycles, much less than the main flash, if I remember rightly. The flash being like where the actual code is stored. Oh, hang on, look at this. It's perfect. Flash memory and data EEPROM endurance. Oh, wait! Never mind, the EEPROM has way more cycles, so it's actually the other way around. So within this range, 100,000 cycles. Okay, maybe it's not something I need to worry about too much. Pin it or put it on the stream title? Yeah, sure. It would be mildly useful if you could display which region a transistor is in without having to hover it. Which region? Which region is it? Oh, like saturated or that kind of thing? I see, I see. Yeah, I guess that would be cool. Does it, wait, does it say that? Hold on a second. Does it say that? Oh, it does say saturation. Hang on a second. Why is it like, it's, this text getting cut off here? I don't seem to be able to like stretch it to make it any, I mean, I can stretch the entire window. Does that work? No, that doesn't even help. Why is the text being cut off here? Interesting. And when we turn this off, cut off, okay. And if I keep this here and we remove that. Oh, why does this keep happening? Man. Maybe I will make a switch actually. Hang on, why is this thing running so quickly? Chill. Saturation. Forward active, cut off. Interesting. I've never seen that before actually on this program. I've never really looked that much about any information on a transistor. That's pretty cool. Yeah, if it could just like maybe show like a little dot or something to the side of it. Or like a shape maybe. Like a triangle or something that changes. Yeah, that'd be pretty cool, wouldn't it? Press / to search for components. Oh my god, thank you so much.
Yuki, get a computer.
That's really nice.
Draw my diagrams. Write my code. Debug my code. Maybe debug my some more. Like you. Develop my software. Hi.
Yes. I'm far from debugging stuff for it yet. I guess this is to kind of help avoid needing to debug stuff that I'm simulating it a bit. Mind you, that'd be debugging hardware rather than software, but yeah. Okay, hold on. Hi, Pragmatic Programmer, welcome. I am Twitch mobiling it bad. Whilst I cook, how are things here? They're going pretty well. Pretty well. Very laid back. You can add the transistor to a scope, right-click properties, show info, show extended info. Properties? Oh wait, like this? Huh? Scope first. Oh! Okay, sorry, I misunderstood what you're saying. Properties, show extended info in this one? Oh my god, okay, I know that does make it show up all the time. I think a little icon would be nice though. Maybe even somehow show it on the graph? As like a shaded region that the line passes through? Mind you, does that happen actually? What's it showing right now? It's showing the... Wait, what voltage is it showing? It's not VCE or VBC or VE? Oh, I'm an idiot. It is, it's VCE. I was looking at the number back at this moment in time instead of the current number. Okay. Okay, neat. I'm gonna remove it now. This is getting very cramped down here. If we need, if we could have some scopes down the side, I guess, so we just move a scope around. But anyway, let's have a look. So, what I was thinking of is that it would be cool to try to implement like wear leveling in the EEPROM. Like, I'm not exactly sure how I would do it, but writing to a different region of EEPROM. I think the EEPROM is probably broken up into like, I don't know what you call it. Undocked scopes. Oh, okay, instead of the scope built in. Yeah, it's so nice. Very, very nice. Let me save this before I forget. Yeah, I think the EEPROM will probably be like separated into, what do you call it, like blocks, for lack of a better term, like maybe like I don't know, 16-byte blocks or something. Maybe I'm wrong, and so writing to one byte would cause it to rewrite all of the other bytes. Pages, yeah, maybe that's the right word. drew the pads sealed. Oh, hang on. Let me show you some things that Seal drew. Hang on. This is extremely on topic right now with this pet long uke. 1 second. Hold on. Wait a sec. Where did I save them? Look at these. Look at this. I give the pats. Look! First of all, it's a long uke asleep under a leaf, which is absolutely how I want her to be sleeping in the pet long uke. It'll look a bit different, of course. I was imagining her sort of being like, you know, maybe like curled up a bit, and then there being like a tall leaf like this or something, I don't know. And then I can't draw. This is why I'm not an artist. For when it's raining like this, the rain would then not... It would stop on the leaf. I know how to do that because of the way that I've implemented support for transparent sprites. I would just secretly... This would be a big sprite that is the color white in this area, so it just draws over the rain, and then, yeah, anyway. Super cute! And then also, just yesterday, I think, he also drew this! Look! Not that one. That's me reaching silver 3. Anyway, look! She's woken up and she's taking a little nibble of the leaf. Ah! It's so cute. Long uke of the jungle. Yeah. Seal drew the Trackmania podium screen. Yeah, it's Thank you for the pasta check and hydrate. Anyway, I thought that was extremely cute. Ah, here we are, look at this. Wait, is this for both flash memory and EEPROM characteristics? Oh wait, there are pages and mentions for a word or half page. Oh, this takes a while. Look at that. A few milliseconds. Oh, it doesn't need the voltage to be super high to be able to do this. That's good. Maximum current peak during the whole programming / erase operation. 2.5 milliamps. Wow, this really does go up, huh? Average during the whole programming erase duration is 700. That's probably what I actually care about. So it's still less than 1 milliamp. Okay. Okay. So we could change this resistor to be... Wait, what's it pulling right now? 300 microns. So if we change this to like 300, then now it's 3,000. Sorry. Then now this is like 860 microns there. But that's just for that's just the current taken by the writing process, right? So it would be plus the maybe 300 microns that it's taking to run usually. So we could just like. Let's call it that to be on the safe side. Oh, sorry, the other way around. No, we need the lower than that still. 2.2k? This is a bit of a worst case scenario. Maybe more than that. Sure. So how long would this last if we were to pull this out now? Simulation speed is way too low. What the hell? Bop. Okay, the simulation speed was in fact not too low. We just need to make these faster. Does this speed them up for all of them? It doesn't, does it? Is there a way to do this for all of them? Save as default. Does not affect the current ones. Do I really need to change these all individually? That's kind of annoying if true. Okay. Pop. This voltage is dropping way too... Hang on a second, what the fuck am I looking at? Why is the capacitor here? What the fuck? How did the capacitor end up there? We didn't even have the backup capacitor in there. Okay, hold on. Let's let it charge up a bit. Or a lot. That's why I was running out so quickly. I didn't realize I'd accidentally taken the capacitor out of the circuit. How did that happen? Okay, now we take the battery out. Boop. Oh my god, it's so gradual. So this is this discharging. This looks like it's gonna last. Wait, how many volts did it say it's okay with? Well, the brownout detection kicks in at 1.8 volts, I think so. Let's not let it go below 2 volts. Okay, so 2 volts is here. So how much time passed between there and there? So this is 3.517. 3.489. We've got like 30 milliseconds. Oh, of course, we can just boost this to something higher than 100 microfarads, I guess. Interesting. We might need to raise it a bit, huh? So that would be enough time to write a bit less than 10 words, I guess. Wait, do we have to erase and then program? Do we have to erase and then program? I guess we do, right? So that's not gonna be much then. So, well, it's about 3 words. Oh my god. We don't have much time, holy crap. It's almost like pulling the battery out makes us run out of power. No, it's not a lot of long U time. That's why I want this to be done with an interrupt. I don't want to be pulling this. What's the main function of the circuit? To give us enough time to write a few bytes of state about the world and stuff in the Petlong Uke project. But only to give that backup power to the microcontroller, not to the other high current stuff up here. So when you pull this out, only this part's being powered. Okay. I want to see more information about the EEPROM stuff. 700 microamps, programming, I guess is that all I care about actually? Data retention after 100,000 cycles. 10 years. A minimum of 30 years? Oh, that's if it's... Wow, what the So you could... Assuming that, like, AA batteries will still be available in 30 years. Oh, don't worry, there's not going to be much stuff. Like, stands and stuff, Prague. It's mostly just so that she carries on from a similar area in the environment that she was in. Yeah. Imagine you take the batteries out and then you put them back in after like 25 years. And she just carries on sliding from where she left off 25 years ago. I hope I can log into my Uke account so I can back up my save on the Uke cloud for 5... No! Absolutely not! You will absolutely not be able to do that. No one will. This thing is not gonna be a smart Internet of Things subscription scumminess. Absolutely not. I'm trying to make it so not like that. Okay. I should probably have a look at this as well. You're telling me this isn't an always online subscription service device that you can break remotely with a false firmware update? I am telling you that. That's exactly what I'm telling you. And it'll last longer for not connecting as well. I mean like battery life rather than just the lifetimes. Something. Let me look up information about EEPROM in this thingy. Introduction. That sounds good. Ah! Right. I can learn about a page or a word is. Not volatile, but after 6 kilobytes. Okay, so it's 2 in hours. An information block. So we're just caring about the EEPROM. Performed by word, half word, or byte granularity. So I assume this is 8, 16, or 32 bits. But granularity of the data EEPROM is 1 word. So yeah, if you were to write byte by byte, then yes, it would need to do the thing where it erases the whole block and then rewrites 3 bytes and just 1 new byte. I guess. Erase operation performed by page. Wait, by page? What does that mean?
Thanks to Elaine for my sad gift.
Hell yeah! Elaine. Thank you very much, Elaine, as well. So thank you very much for the resub X. Hi. I just elbowed my desk. Hello. How are you doing? Alright. Welcome. And that trying to unlock the bootloader isn't going to be a felony in the US. I don't know what the US is doing with their laws, but I'm certainly not gonna, like, what's the word? Pursue anything like that. Oh, it has like some, this is pretty interesting. Wait, interface. 6 bits stored for every word to recognize and correct just 1 error. Interesting, so it kind of has some, redundancy built in. Okay, so we have enough time currently to store 3 words, which would be 3, 6, 9, 12 bytes. We have enough time to store 12 bytes. This is kind of crazy to think about. I might want to increase that capacitance. How long does it last if we bump this to 470? Realistically, we're probably not going to go any higher than that. Plop. This does take a while to charge, doesn't it? Look at that. String. Maximum of about 15 milliamps. That's the memory anyone would ever need. Well, it shouldn't need to be much. We'll need to store the seed of the world, which is probably going to be 32 bits, so that's already a third of everything. And we'll need to store, like, some value that represents how far through the world we are, which is probably going to be another 32-bit thing. Those are going to be the main 2 states, though. I don't know exactly how to do this yet. This is going to be an interesting stream where I try to work this out, but hold on, let's pull the battery out and see how long it takes. I'll last. Boop. Hang on a second. So we pulled the battery out at 7.56, let's see. So 7.56. And we're waiting for the green line to drop below 2, I guess. Or is it lasting a lot longer? 5, 4, 3, 2, 1, 2. Okay, so now we're at 7.695 minus this. Okay, nice. That's a lot more time. So if it has to erase and program a whole word, and one erase program takes about 4 milliseconds, then 1 word gets done in 8 milliseconds. So if we divide this by, well, let's multiply by 1080 milliseconds, then divide it by 8. We can write about 16 words before we run out of power. Which is 64 bytes. That's a lot better. I mean, that should be more than enough. It really should be more than enough. I don't know. Boop. Let me just have a look at that. The peak here is... Oh, we never finished discharging, did it? Let's let it finish discharging. Pew. It's pulling at the worst there around 58 milliamps, which is still fine, probably. I mean, I'm sure I can find a transistor that's okay with that for such a short amount of time. And then once this is done, what's the peak? I'm hoping that it doesn't get above 15 milliamps. That's what I was trying to limit this to because of the limit of this diode. Boop. 10. That should be fine. It's so fun watching these lines cross over. I don't know why. It's also really satisfying watching these horizontal lines appear to go across constantly as I drag the mouse. Do you have a way to find out how much you would need to store? That would help a lot. No, I haven't decided on that yet. But I'm thinking it would only need to be 2 words. But I guess there can be some additional things. Like maybe there'll be a couple of user settings like sound on or off, I guess, will be a setting that's a single bit, obviously. What other things? Maybe there could be a setting for like... Maybe there could be a setting for... Do I want to do this? Maybe we could have a setting for how long to keep the screen on for since the last interaction before it turns off. But like one of the main attractions to me of doing this project was that it would be permanently on just the whole time. This is why I've been trying so hard to minimize the current consumption. Because with how I'm currently planning on building it, it should be able to last for like over 4 months, just always on and always playing up to 1 hour of audio non-stop per day. If I remember rightly, it was 1 hour that I accounted for. On 3 AA batteries. That was assuming... I can't remember, that was assuming 2,000 something 100 milliamp hours batteries. I can't remember exactly what I assumed. So yeah, maybe I won't have a setting for that. There might be a few other settings though, I'm not sure. But yeah, it's going to be very interesting when I get to the point where I'm like, how do the worlds get generated? So Whoa! Hi Chaos! Welcome! How was stream? Femboy Cabot, a Pyrodroid. I still love the Cabot. Hi! How was stream, Chaos? Welcome, or welcome back, question mark? No, I don't think welcome back. My memory is so terrible, I'm really sorry. Boop. Whoa! Oh my god, it's the thing I've been seeing everywhere recently. I'm gonna give headpads to this. And I'm gonna give headpads to you. I love this avatar. Why do you keep jumping into this spiky death pit? Why do you?
Cheese?
That
Cheese.
seems painful, much like the cheese that's being thrown at my face. Welcome there.
Cheese.
How was stream? Look, dots go brrr. How was your stream? Hope it went well. I'm a weird cat that's trying to plan a little physical digital pet very legally distinct from Tamagotchi. and stuff. Those shiny treasures for doing the spiky pit. Ah! Was it like you were trying to like get close to the something like were you trying to sort of like, if there are spikes, was it like this like treasure here that's meant to be like a treasure chest, not a mushroom or something else? Wait, how do I draw this again? I guess it'd be like that. Holy crap, that's almost art. Perfect. And it's a spoiler, it's actually a mimic, so there are like nice tentacles here. Anyway, and you like come down like this and then like have to grab and somehow get back up? Is that how it was? It was a long deep pit with lots of spikes and you had to go all the way back to the top and just... Ah! I see. An endurance challenge, kind of. What is hurt? Well, I hope you managed. Yeah. Well, welcome in, I'm a weird cat. And, I'm doing what I've already said. I just realized I'm repeating myself, sorry. I look like your circuit a bit. It's funny. Okay. But yeah, it's gonna be very interesting when I try to work out how to do the world generation stuff, which is not really generating a world as much as it is basing it on randomness. Kind of. A pseudo-random number generator. Thank you very much for the posture check and hydration. Yeah, one text you. I'll say after this. Is art but good? Oh, I see.
Yeah.
But yeah, please take care of yourself. Hydrate, save the kidneys, stretch, eat, and maybe look at something other than the screen for a bit if you need to. That goes for the people who have come from the raid, as well as the people... Oh, well, as well as Chaos. Thank you for the pats. My cheese. So, yeah. So I'm thinking that the world gen will be based off, like... a 32-bit random number for a start. That's just a seed. Something that is made when it first turns on. I'll look at my other screen for a bit. Yeah, please do the self-care. Thank you, Chaos. So it makes a 32-bit number once at startup, and then that basically is gonna have a knock-on effect on everything in the world in terms of like the terrain. And by terrain, I basically just mean where there are trees and where there are plants and rocks, and so I don't really know what else there'll be. And yeah, I'm not really sure how this will work. I guess it's something in a similar vein to hashing algorithms. But we're obviously not going to want to calculate the entire world in memory, because it's like an infinitely big thing, and by infinitely I mean 32 bits. Could use the program memory itself as the map data? Just like for randomness? Is that what you mean? That would be interesting. I already have code that uses the pseudo-random number generator though. Oh, sorry, the true random number generator. The true random number generator. This thing has a true random number generator, which is really cool. This is when I was doing it. And to be able to do that, I have to turn this thing on in it. So the true random number generator gave this, and then I would run that. From this point on, I would just use this as I just do this once and power up, and then use this to initialize the pseudo-random number generator. Basically. Anyway, you just read the bytes and interpret it as something. Yeah. I see what you mean, but there's no guarantee that those are not going to be highly biased. Or like, you know, maybe every fourth is often said, and I don't know. But anyway, it's going to be based on the random seed and a current position through it as she like slides. So I guess it's going to keep ticking up. Thanks, Frank. Because it takes like extra power and time to do the true random number generator, so I just use the pseudo random one because it's much faster from that point on. But yeah, I feel like I'm gonna have to learn a whole bunch about this kind of generative stuff, world generation stuff. I feel like there's probably like a lot of algorithms. I don't know if... I wonder if I should look into Minecraft's way of doing it. Because I know that it does something like that, where the world doesn't exist until you get close to it, and then it does have to generate a whole bunch of it, because it's like, you need to be able to see far into the distance, but we won't need to generate much with the Petlong Yuk, because we can't see very far, and we shouldn't ever...
Cheese.
That's true, you should never cheese me. We shouldn't ever need to store that for any long period of time, because she's not going to go backwards. That's one of the things that I'm planning, that she only heads in one direction, just for ease of calculations. I guess she could, but I think it wouldn't be that bad if she just keeps on heading in one direction. It's one hell of a big park that she's in. And in realistic, if you want to think of it in a more realistic way, it could just be that she's very slowly turning left the whole time, so she's really just doing rings around the park. And the ring loops after 4 billion frames. You probably need something like an Elite, as they did a lot of stuff in small amounts of memory. Maybe. I specifically want it to not be predictable, though. You know, I don't want to like have to hand code things. Thank you for the pat sexo. I do hang on a second. I also finished eating. Hang on. Also, I finished the cooking and eating. Time to return to the school grind. There's an assignment due tomorrow. Oh no! That wasn't put on any of the trackers. What the hell? Is that legal? Good luck, Prag. Go look at my small screen. Have a nice phone, Stewie. A video on JVidX9 about plate generations. Planet generations. Plate generations. Okay. I make a note about this. If you like have the specific videos to hand, I'd very much appreciate it if you could like drop it in stream chat. Because as I'm sure you know how terrible my memory is, and I'll probably forget these things. The links are blocked here. But wait, is Hobgoblin in the Discord? Probably not, right? Oh, you are in the Discord. Would you mind dropping that in stream share? If possible? Stream chat? If possible? Okay. Thank you very much, Prakprok. What was I going to say? Oh yeah. So, I only want it to be predictable in to some extent. Like, I don't want there to be like, you know, I don't have to be sliding for like 10 minutes before you see another tree, for example, you know. So I want it to be some restraints that like you're guaranteed to see a tree every, I don't know, 500 pixels scrolled or something. That kind of thing. Yeah, that's not what I'm planning on doing tonight though. I'm not really planning on doing anything much more tonight now that this circuit works. Oh, I guess I could give you an update on the other circuit that I was trying to reverse engineer. A completely different topic aside from the fact that it's also a circuit. I was trying to reverse engineer the tense machine circuit. Here's what I have so far. Some of it is a little bit tentative or assuming that some things are transistors when I'm not entirely sure. I might as well just put this big. One more thing, instead of a transistor to switch the voltage divider, you can connect the ground of the resistor to to another IO pin. One sec. You have to connect the ground of the resistor, so this, to another IO pin. Set the pin as a low output when you want to read the ADC instead. Oh, that's nice! Oh, that's really nice. That's really nice. My only concern is that the voltage here might be too high for that. The whole reason that I'm using the voltage divider in the first place is that the voltage might be too high for this. I mean, the ADC I think can use like a lower voltage than the other IO pins anyway. But I'm also not sure about this. So if you had to put in like a really highly charged 1.5 volt battery, let's get those graphs back up about the batteries. Okay, so this would be like super worst case, this one. Because these lithium ones are like really high. 1.7 times 3 would be 5.1 volts. Oh wait, that's not even that bad. That's not even that bad. This is like super worst case. 5.1 volts, that's not even that bad. Maybe a 5 volt tolerant pin would be within spec. I mean, maybe that would be within spec for a 5 volt tolerant pin. Let me look at the electrical characteristics of this thingy again. Where are we? Input voltage on FT, this is the 5 volt tolerant, and FTF, this is 5 volt tolerant fast pins. VDD plus 4 volts. Would you look at that? Would you look at that? That should be fine, right? Ah, except at startup. Except at startup. This would be a problem at startup. At the very beginning, this would be a problem. Because... Welcome in, Avenel. Welcome. The resistor will limit the current, so the voltage will be less. We didn't... I mean, we're not going to be pulling much current at all, right? The pins start as high impedance. That's true, but wouldn't you still damage it even if it's high impedance? Just by having a voltage present there? Let me make a new circuit diagram. Oh my god, it launches a new window now. I'm not sure what I was expecting, to be honest. Well, I was expecting it to just... remove everything. Can you stop selecting text? Thank you. The ESD diodes will protect the pin at low current. Ah, this sounds scary. I don't like the idea of going above the maximum, absolute maximum ratings. The voltage won't ever get that high. Well, the thing is, at the very beginning, the voltage could be 5.1 volts, and the voltage on the power supply pin here would be 0 volts, just for a tiny moment. Before the regulator kicks in and when the capacitor is still charging a bit. Like, the very first thing that happens is this will go to, like, worst case 5.1 volts. At the pin itself. Wait, hang on. You're meaning this pin though, right? Because if this is going to end up being connected to this as well, right? I wanna draw this out. 5.1, let's assume. Don't know what values I'd use for this. Probably pretty high because I wanted to use as little power as possible. However, this would only be being turned on for like a tiny fraction of a second every quite a lot of seconds, so I guess it doesn't really matter if they're like 10k or something. Sure, let me just pluck the value 10k out of my anus. There it is. 10k. And I'm not sure what voltage it needs to be down to, so let's just make the other one 10k as well. Okay. What am I doing? Get off. Yeah, no, you stay there, you move, yes. Except this is not going to be going to ground up here anymore. It will be going to there. This will be coming down to the ADC. How do I model the flipping microcontroller in this situation? Let me make this a bit smaller. Oh god, that's not quite the same size. My OCD would never let me. So basically this will be coming... Oh, why does that keep happening? What am I pressing? Is it 2? Am I pressing 2? Okay, 2 does that. 1 does that. Not gate, an AND gate. 3 does... I guess that's OR. I don't remember this one before. Is that an inverter there? Wait, or is that XOR? That's OR. That's XOR. Oh my god, there's a moth flying around. Five is the selection, 6, yeah, everything else. Oh no, it's not, never mind. I didn't fast forward or anything. Okay, so this will come in there, this will be coming down to the microcontroller. This would be going to the switching between low or floating pin whenever I want to get a measurement. It is nice to not need a transistor. That would be a very neat trick. I'm scared. Scared! Especially since for testing, even though I have a bunch of... Why do these not have extensions? Especially because even though I do have a bunch of spares, I got 10 of these STM32s. I broke one when I was first trying to solder it, so now I have 8 spares. Man, the soldering is a real pain. Although I guess I did kind of figure out a technique eventually. It would still take me like probably an hour or so to solder a new one onto the breakout board. Also, I've only got one more breakout board, I think. Or is it 2? I don't know. Alright, so we would measure between here and here. You're saying the current would drop the voltage. You mean the current just caused by... Oh yeah, right, I need to think about the maximum current through the pins now, don't I? Of course, okay, I see what you mean, yeah, it will be... Okay. I haven't done this idea before, so I didn't really understand what you meant about the voltage dropping because of the current. But yeah, of course, if the pin is pulled low, it's basically shorting through the resistors. So effectively, this will be happening. Is this running? Yeah. So the voltage that this would see between... Wait, no. Thank you for the pat, Sunseal. What I care about is... Well, this pin here... You know, this bridge here is happening inside the microcontroller, so... This is just going to be 0 volts. Let's say the resistor is 100k. The current will be at most 50 microamps into the pin. The protection diodes will handle it easily. See the pickup post? Okay, let me have a look. Example of internal protection diodes in the micro. Oh. Okay. Can get rid of this. Not really. What a waste of space. Oh, what a waste of. What is this layout? Okay, fine. Electrostatic discharge is unintended quick. Blah 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 blah. Unintended quick high voltage repair on conductors. Because of static electricity, right? High voltage and current peaks. Okay. Scroll down to internal diodes section. Internal diodes. Is it this? Oh my goodness. Inbuilt protection is very common on CMOS I/O pins that may be part of a device. Anything from a simple load switch to a medium complexity microcontroller to a high complexity FPGA. There are normally 2 per I/O pin. One attached between the pin and ground. One attached between the pin and ground. So this is the pin, and that's ground, I guess. And one attached between the pin and VCC. Both are reverse biased under normal operating conditions. Ah, is this like relying on their reverse breakdown voltage? So that if this is suddenly like above, say, I don't know, 100 volts, it's gonna go straight in through this down to ground? Both are reverse biased under normal operating conditions. Wait, what does that mean exactly? Ground is less than or equal to VIO. Voltage is high. Okay. If the pin goes more than VCC plus 0.6 volts, then it protects the pin. I mean, if this is the case, why are there limits in the datasheet? Is it because it would start damaging, the diode can only handle it for a small amount of time? You serve to protect the sensitive CMOS logic in the case of a fault condition. You only handle so much current. Ah! Okay. Okay, so yeah, there'd only be very little current flowing through this. Well, I mean, there'd be less if it was 100k. Well, 255 microamps still. The idea of relying on these things that are just meant to protect things in a full condition feels really bad to me. I mean, I guess I could just include my own diode. Guess I could just include my own diode, huh? It's only for a very short time too. Well, that's assuming that my programming works. I don't know how long it's actually going to be like that. These times you'd have quite a low maximum current. What does it mean? What is quite a low current? You talking a milliamp? You talking 100 microamps? Talking 10 milliamps? Exceeding this maximum current will blow the SD diode, usually causing it to go open second. Removing the protection. And then the CMOS gets fried. Okay, yeah, that makes sense. Huh. I wonder if that's what let out the magic smoke when I accidentally sent like 12 volts into... when I accidentally sent 12 volts into one of the IO pins of my Arduino Mega one time. It still works, by the way, that Arduino, which is insane. I don't understand how it still works. I guess something broke, but it hasn't caused a problem yet. Huh. That was a long time ago. That was a really long time ago. Okay. However useful they may be, they also generate design challenges and therefore require careful consideration. The two scenarios which cause problems are when pairing up a circuit with multiple voltage rails. That sounds a little bit like mine right now. When the voltage on I/O could at some point be higher than VCC because of the nature of the incoming signal. Could that happen here? Well, the wires that are going to be connected from the amp specifically are going to be the, like the audio thingy. One of those is going to be connected to ground. The other one is going to be connected to the ADC. Oh, I mean the DAC, sorry, the DAC of this. And the only other wire that's going to be connected is the enable pin. I mean, I guess I could measure it from the... I have the amp that I want to use. Although I can't easily test this because the little breakout board that I bought for this, for easily testing it, has an internal pull down, I want to say, resistor on the enable pin because I think it's active low. Can't remember, to be honest. Thank you for the pants. Hi, Geets. Welcome. Hi.
Cheese.
Why? LCD has loads of pins, so who knows? But I can actually just measure from the LCD. So what do I want to measure? What's the problem condition? The problem is if it's getting power, but we're not pulling the pin in either direction for the IO pin. With this, is that the situation you were talking about earlier? But also, if I were wanting to be like super careful, I guess I could just use like a Xena diode myself. Although I wouldn't really help, would it? Wait, if I put a Xena diode here, this is not going to be dividing the voltage properly anymore, so that kind of defeats the point of the voltage divider. Curious about how it would actually work. Well, I guess the voltage here would only get down to, say, 3 volts, and then you'd be seeing the difference between 3 volts and this instead of 0 volts and this. Okay, whatever. Have a nice sleep on this. Thank you very much for the pats, and thank you for hanging out for so long. Which pins are 5-volt tolerant? How many pins are 5-volt tolerant, actually? Out of curiosity. Because, maybe there are just so many. Maybe I could just get away with using only those pins. I think there are quite a lot. Oh, there's so many! Okay, the vast majority are 5-volt tolerant, actually. The vast majority are 5-volt tolerant. But I guess SPI and stuff, there will be some SPIs, and I have to use mine. Even these SPIs are 5-volt tolerant. These ones. Okay, I think we'll probably be fine. We shouldn't need to worry about stuff backfeeding through the IO pins into this. That should be fine. That should be fine. Because this is only ever going to be 3 volts or less. And we know the 5-volt tolerant pins are fine with up to 4 volts over the input, so this area will be fine. The only area that I'm now worried about is, I guess, this area. Especially if we're not using a transistor, but instead connecting it down to a ground pin, which is, it's neat, but I'm scared. I'm scared. I wish this website would say something about like what a low maximum current actually means. Backpowering. It's a phenomenon which occurs in circuits that selectively turn off voltage rails as part of its normal operation. Even though you've turned the linear voltage off, the circuit still remains powered. What? I hate this. If the leakage current through any... hold on. This actually would be happening here for a moment. When you first turn off the circuit, when you first pull the battery out, this capacitor here will still be powering it for a moment, so there would be still some coming through here. This is horrible actually. That means that we might not immediately see that this has been disconnected until this runs out. I'm gonna need to test this in real life, aren't I? I think I'm gonna need to actually test this. I'm gonna have to make a small circuit board with these actual components on them. Man. That's gonna suck. It's more about a total energy than current. A large current for a small duration or a smaller current for a longer time. Okay. I just... I don't want to be in a situation where a mistake in my code kills the STM32 because I accidentally keep this pin low for a long time. Hang on. This is transient voltage suppression, right? This is actually something that I wanted to do for the battery compartment. In case, because you're supposed to protect things that are exposed, right? That a user could touch. I think the only part that will be easy to do that with in my Petlong Uke thingy, when it's fully made with a case, will be the battery compartment, well, the battery terminals. When you're changing the battery, you could easily touch the things there, and if your body is charged or static, that you could give the Long Uke the bad zappies. So one of those diodes across the battery compartment terminals, battery terminals. Why do I keep saying compartment? Across the battery terminals would be good. That's actually a thing that I want. Blow a fuse though. Please replace the fuse in your Petlong Uke. Well, how can I know how much voltage someone's gonna be charged with? Let me read that thing about backpowering again. Or can actually read it this time. If the leakage current through any CMOS ESC diodes onto the unpowered rail is large enough, the circuit may begin backpowering itself. You can normally diagnose this by noting that the unpowered rail will be 1 diode forward voltage drop, less than the voltage. Okay. What is this? Extra diodes can be added to prevent leakage currents through the CMOS ones on devices which have blah 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 blah. ESD protection diodes to VC ground. Alright, looking at here. Is this the microcontroller itself? And your one, and another one. I guess? Series resistance into CMOS IO. Wait, is this the kind of thing that I'm looking at right now? Here? Sounds similar. But I guess not, because it's talking about scary things. Wait, what? Somewhat counterintuitively, as resistance as small as 50 ohms can double the immunity. Wait, why would... Huh. Well, I guess it is gonna be a very low current device. I wonder if we could get away with like a resistor in the power supply. In the power input part. Hmm. Oh shit, I forgot that I was planning on maybe having capacitive touch stuff. Ah, I completely forgot about that. Oh. Typically used to simulate a lightning strike? Holy crap, what the? Please don't let your pet long nukes get struck by lightning, oh my goodness. This sounds possibly useful as well. I should probably look at this sometime off stream. Okay, that looks like useful information. Thank you very much for posting it, Hop. Ah, thank you also, Hop and Bonmas, for posting stuff about the procedural generation as well. Definitely gonna check that. That's gonna be some... Yeah, I'm looking forward to that, actually. Okay. Well, I'm not sure how much more I was planning on doing today. Nothing really. Let me just go through what I think that I've reverse engineered from the tints machine, though. Yeah, let me just this is off topic from what I was doing, but this is today, but this is what I was doing for like several days, and while I was gate crashing Doohoo's stream as well. I call it gate crashing, but hanging out basically. Let's open this up. Where is this? Hold on. Oh! Okay, let's see. I don't get this in view properly. Do I even need this in view? Do I need to show you this? Probably not. Well, anyway. Anyway, ignoring that, let's just look at this instead. So, there is a switched... So this is a thing that runs on like a 9-volt battery, right? And there's a microcontroller in it. And the microcontroller makes small pulses from like 50 to 300 microseconds. At regular intervals, you can set the width of the pulses. You can also set the interval. And then it like puts those tiny little pulses, which are switched from the battery, basically. It puts those through a transformer, a step-up transformer. Okay, let me close some things again. I've got too much open. Get out of here. You can go as well, Long Yuk. You're free. Be free. Be free. 1 sec. Projects. This one. Photos. Okay, yeah, so there's the microcontroller. And those are the transformers. This is 2 different test machines. They've got a different microcontroller and they work basically in the same way. Anyway, the routing's different. Anyway, so the pulse goes through this. When it comes out the other side, it's higher voltage. 100 and something volts typically open circuit, but it's current limited, so when you have it connected to yourself, which is the point of the test machine, you know, the voltage drops. Your VTuber model is the most sophisticated hand and ear movements that I've ever seen. Aww, thank you. I feel like my ears are moving too much recently. But thank you. Thank you very much for the pads. Aww. Also, welcome in, Rookie. Sinish. Hi. Hi, Exia as well. Thank you for all these pads. Oh my goodness. Look, my ear gets moved by the hand as well. It also clips through the hand a bit. Don't look too closely. Shh. 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 Hang on. My sophisticated hand tracking is fading. Shh. No. Yeah, there. Shh. Oh. Shh. Perfect. I wasn't tracking my finger sticking up. Okay, so yeah, that's basically all. However, the circuit, there's a lot of stuff going on. So there's this 8 volts is just what I was measuring from the battery, because the battery's a bit low. It's a 9-volt battery, but I was measuring 8 volts. Somewhere, somehow, the voltage gets switched. It's not the main like 8 volts supply is not just from these switches at the top here, which is like how you turn it on.
Check that pad. Plant mat. Error. England error detectment. Restart my language.
Ah, damn, I didn't stop the music in time. I thought she was going to be stuttering for longer. Pad cabbage. Don't worry. The England language is difficult. Thank you for the pads, thanks as well. So I'm not quite sure. I haven't tracked where the power comes from yet. Like, I've done all this crap and I still don't know where the power comes from. Anyway. There is a voltage regulator. It's this thing. It's one of only 2 components that I'm absolutely certain about the identity of. And that makes the 3.1 volts that the microcontroller runs on. And so yeah, switch power comes from somewhere. I'm not sure yet. So I'm just writing this as the switch power. Some component is here. I don't know what it is. Something, I don't know. Is this thing? Thank you for the pads. I love how this looks like she's just like really awkwardly like lifting her hand like this. It's like pat. Anyway. Stuff. Anyway, it goes through a diode. There's this resistor array here, which is this resistor array here. And then the other side of this resistor array is used to pull some lines high. So there's this little chip here. I'm not sure what it is. It might be an IO expander. Mesaka thinks it looks like an IO expander. I think it could be a DAC, or it could be like a watchdog kind of thing. The end result is that it appears to put a voltage out on some pins under some conditions. And I have measured serial data being sent to it. It sends it's receiving like 2 bytes over and over. What I want to do is put the tense machine through different modes and see if those bytes change as the electrodes do different things. Dopuke tries her best to pat that cat? Yes, she does. So there are these 3 lines here that are coming from the microcontroller. And normally there is... Oh yeah, and right, there's the one that looks like a latch because it pulses after each byte. Anyway, so these 3 lines from the microcontroller come along here. These are like low by default, and this is high by default. That's what that line above it means. And then it goes through these transistors, and these transistors, when they're turned on... Oh, by the way, there's like a resistor somewhere along this line. I haven't traced it out yet. There's a bunch of transistors, resistors next to the microcontroller here that I think a bunch of these lines go through before they get onto the backside. Here. I/O opener? Did you say? Extender, I/O extender. Basically, if you don't have enough I/O pins, you can send commands to something else that will output them. But I think it's probably a DAC. Digital to analog converter. I guess you could call it an... Oh my god, an eye opener. Amazing. Squish that yolk. All you need to do is squish that yolk. Look at that face. All you have to do is squish that cat. It's even flipping left and right, I think. Yeah, it is. Okay, so what ends up happening is because these ends of the transistor are pulled high. Oh, I think I've failed to connect this. This probably needs this connected there, or I might need this one connected there. One of these connects to here. Anyway, all three of them are pulled high. And oh, wait, have I marked it on here actually? Yes, this one. Okay, so it's the one next to 0 o'clock is pulling it high. So this one is 0 o'clock, so it's this one. Okay, there we are. Let's just fix that. So, yeah, so basically what happens is these transistors invert the signal, because when this is off, the transistor's not pulling this high voltage down to ground, and when this goes high, the transistor is pulling this high voltage down to ground. By high voltage, I mean 8 volts. Or it's less after it's gone through this diode, but whatever. And so, yeah, so then this ends up receiving inverted serial data, inverted serial clock, and uninverted latch. I don't know why they do that for this. I would have thought you can just pass the latch or whatever. Anyway, out of this come 2 voltages, and basically this is repeated twice. I just haven't done the other half yet, so one of them comes over here, another one comes out and would go over here, you know, somewhere over here. That's the same circuit. So, yeah. Switch power comes in, so normally there's like somewhere around 5 volts coming out of here, right? And the switch power comes in here, so this is like around 8 volts, probably 9 volts normally, but the battery's low, you know. And I actually could not see a resistor between these two, which is weird. I don't know why it's going directly into the base of the transistor. I don't understand why that's possible and without damaging the transistor or this. So maybe there is a resistor somehow. Maybe this is current limited. I don't know. I'm gonna go to sleep now. 9 ideal. Don't stay till 5 AM. I'm gonna try my best. Oh my god, it's nearly 4 AM. Okay, yeah. I'm just gonna be ending after showing this anyway, but I really wanted to show this. Thank you very much for hanging out there, Maki. Have a nice sleep. Also, high cold syntax. How would one get into electrical engineering? I don't know. I'm gonna be honest. I just kind of... Well, I was mentioning earlier about a YouTube channel called Big Clive on YouTube. And... but I was into electronics far before then. Like when I was a child, my mum got me a book from a place. Oh, wait, I won't mention that. She got it from somewhere. And it was an illegal way, not an illegal way. Anyway, so and it was like called the Osborne Introduction to Electronics. And yeah. I guess, but I was already interested in electronics at that point. She didn't just get it for no reason, so I would already have been into it. But at that age, obviously, I wasn't engineering anything. I barely understood anything, and I tried to make things work and stuff. So actually getting into the engineering part, definitely watching people do things like teardowns and reverse engineering of things has helped, because they, you know, by someone like Big Clive on YouTube who actually explains what's happening. But also I had a friend who explained a few things. I got into like Arduino stuff some time ago, although I was doing some electronic stuff before I had an Arduino. Yeah. Osborne, yeah, Osborne, yeah. US, how was it even spelled actually? Osborne Introduction to Electronics. Oh, this is so nostalgic. Wow, what an amazing. Oh, okay, let's maybe not share this because it's a bit doxing. Anyway, this is the amazing thumbnail that's on Amazon. What fantastic quality. But yeah, that's what it looked like, just a little less blurry. Anyway, USBORNE is how it's spelled.
Adim her lamp still glows, quite Hammer's focus grows, Yuki bends. Adim her lamp still glows, quite Hammer's focus grows, Yuki bends with tireless mind sketching traces. Lines align, circuits bloom beneath her hand. Tiny worlds at her command, while others sleep in nightly span. She crafts her Agadim.
The eam. At 3 AM. Thank you, Nuge. That's very kind. Welcome, Nuge. I hope you're doing alright. I love all your little poems. I'm not actually doing the reverse engineering today. I was doing my own stuff. I'm just showing what I've done currently. So let's call it 8 volts comes in. And if this is, so it's going to go through like a series of checks basically. So that's what I'm thinking that it is. So if this says that it should be on, then 8 volts continues along to the next transistor. And whether it then continues further is determined by this. This here is the main pulse from the microcontroller. This is like, this just goes like low most of the time and a tiny high whenever there should be a spike. Did you hear my wrist? Amazing. There's still a cat on my big screen. Oh my goodness. I will do those things shortly. Thank you, Stu. So this is the main one, but it will only do anything if this says that stuff should be happening, right? If it does, then these two things get combined effectively by this transistor. Again, I don't know how this isn't destroying this transistor or this one. There is no resistor here that I could see. I don't understand why this is not destroying the transistor. Just current going straight in there, so that I must be getting something wrong. I don't know. But anyway. Oh, hang on a second. Wait a minute, there's a mistake here. Oh no, it's not, it's because it's PNP. Right, this one's PNP. I got confused for a second. Okay, yeah, so the roll is reversed. Emitter through to the... Emitter? I barely know her. Maybe this is current limited. Maybe this entire thing is current limited and that's why this doesn't need a resistor. So it's going to go through there, and out to there. Anyway. So actually this turns on when this is pulled low then, right? If this is high, this would not be on. Huh. I'm gonna have to do some more. Oh, wait, no, that's correct. That's correct. So this is normally... Oh, let me double check. Oh, I'm not sure, man. I'm not sure. Anyway, then it goes through the dial for strength and stuff, and another little one that makes sure that even if this is dialed up to maximum 0 ohms, it still actually is current limited. And then finally, there is normally like the 8 volts roughly across this step-up transformer. because, you know, it just flows through and goes to the other side, but then it has nowhere to go, so it doesn't actually draw any current through it until this transistor turns on and then pulls this to ground, and now you have 8 volts on one side and 0 volts on the other, and so that actually we get current flowing through this, and we get the zap out of the other side, and then there's also this diode across it to protect the transistor, and I guess the entire rest of the circuit from the beefy negative pulse that happens when you cut the power to this, because it's a coil, it's inductive, so it does that. And over here there's a couple of things. There's this thing here, which is I've started tracing out the circuit for the beeper thingy, the little piezo thingy. This is similar to the thingy. It has like the switch powered to the 8 volts across it normally. Wait, is that right? Is that right? Yeah, it is. Yeah, it is. I guess because this is piezo, it does not draw current except for at the moment when the voltage changes. I'm guessing. I don't really know how these things behave. And then this gets switched down to ground. Or maybe this usually just... Maybe this transistor is just usually on. So this side is being pulled down to ground, and then only when this transistor turns off, I mean, like, it occasionally turns off in order to allow that up to there. I don't know why I've done it that way, but they have. And then there's, I don't know what the hell this is. This stuff is not connected because I don't know if this is the correct type of transistor, but there's an area that looks like that. Anyway, I don't know if I'm going to continue doing this because frankly it's very head hurty and stuff, but that's all I've done so far. Yay! Thanks for going to my TED Talk. Let me hydrate and posture check. Thank you for the stretch as well. Well, posture check. Maybe I should rename it to stretch actually. I don't know, why am I so high up? I'm not even looking at the... There we are. Now I'm looking at you. Now I'm looking at you. Now I'm looking at you. I love the fact that I can do that now. I flipping love the ability to do this. Hi! Hold on, can I do this? Not really. Hydrate and check my pasta. Yeah. Stretch, I make the Luke younger. Make me look younger. Please don't stretch your long Luke. Let her grow at her own rate. But yeah, I guess I'll end for now. I guess I'll be wrapping up right about now. Thank you all so much for hanging out. What would be the next thing that I do? I guess I want to be... it would kind of be nice to be able to test that circuit, but I don't know if I can really test it super accurately. Like there might still be things that go wrong when I use the real regulator and stuff. What's the Young's modulus of a long yuga? What is Young's modulus? Anyway, I'm gonna refund you for the saving the kidney stream because I'm about to do it. Anyway, how about I do that? Anyway, where is the reward queue? Here it is.
Reject.
Also known as refund. Also, reject monies. Yeah, I'm sorry. Right, who can I pass you on to? Oh yeah, right, hang on, not yet, Yuke. Not yet. Finish a single train of thought. Oh my god. So next, I guess I could try looking into level generation. I probably want to make a mock-up, like, you know, not on the thingy first. So maybe I'll make like a C program or something that prints out a text file or something where each character is a certain thing, like a tree or something. Then I can just read the text file, rather than actually make it on the thing. Ah, speaking of which, I guess I should actually do a stream where I draw a bunch of little pixel art for it as well. Trees and rocks and stuff, basically. That's mostly it. It's kind of the spring constant of a material. Oh, okay. Well, yeah, how springy is she? If you go like this, does she go like... Please don't do that. No. Gotta take care of your long uke. No long uke abuse. Alright, I should pass you on to somebody now, but thank you all so much for hanging out for so long. I feel like I didn't really do much, but it was kind of a nice, pretty relaxed return to streaming. It's been less than a week, but... yeah. It feels like it's been a while. Oops, that's a bit loud. Who should I be passing you on to? Who should I pass you on to? It's been a long time since I rated Ayabu. Ayabu is on. Freedom Studios on as well, which is pretty cool. Who is pretty cool, I should say. I wonder. What if I just search Twitch for electronics? I don't know how to like search for... Oh, there. I was about to say, I don't know how to search for channels tagged electronics, and literally the text search for channels tagged electronics appeared, so yeah, okay. I get it. Alas, alias. There are no VTubers doing electronics. The only VTubers I know that do electronics are Linted, who's unfortunately not streaming, Oriana Aura, who is unfortunately not streaming, but it's not much of a surprise because she raided into me, and myself. Oh no way, Aaron just... Perfect. We have a raid target. Aaron just started streaming right now. Actually, he's been live for 3 minutes, 30 seconds. Shush, silence! But I didn't see him show up in my list of people until I went to a new page. Apparently, strange. Alright, we're gonna raid Erend. So Erend is the person that I make music mixes for sometimes. I've made 4 mixes so far and I'm working on a 5th. Yeah, I basically mix existing music, not my own music. I do make my own music, but I don't make that for Erend. I mean, I would if he commissioned me, but... Anyway, I make mixes, often drum and bass, hardstyle, and hardcore. And who knows, maybe I'll play one of my mixes tonight, who knows. Anyway, I'm working on a 5th one, and it's got a lot of silliness in it. I'm thinking of calling that mix the Fun Allowed mix, as opposed to No Fun Allowed. Not that I've ever done a stream which is a mix that is no fun allowed. Anyway, we're going over to Erend now. Erend is working on a tower defense game in Godot. And yep, that's where we're going. So it is somewhat related. It is technical devy stuff. So that's where we're going. Raid Erend. Shout out Erend. I don't want to... Why are you looking at me, Erend? Here's where we're going. I haven't just been scared of raiding people who are not VTubers. Erend is not a VTuber, however, he is cool. So there we are. He's not a dog though. Small man looks at growing to-do list and chooses stupidest available task. There you go. How could you resist such a self-deprecating raid target, huh? Raid message can be... what should the raid message be? We were doing electronic stuff? I don't know. How about the raid message is just a Nyan? And I'm making it that simple because when Erend raids out to people, his raid message is just hi. Which I just realized is actually on his profile as well. Alright, raid message is just Nyan. Let's make it capital letters because his hi is capital letters. So there we go. Raid message is Nyan. If you want, you can make it derp and or any other emote afterwards. But that's the raid message. Thank you all very much for hanging out. Yeah, that's all for now. I'm gonna try and stream again this week, as always, but I don't know when. by your good stream. Thank you very much. Thank you, Sian. I'm glad you enjoyed it. Yeah. Bye, everybody. Bye. Read messages, Nyan. That's all. Okay. Bye. Pew. You're all super kind. I super appreciate you hanging out. I'm gonna save the kitties. I promise. I'm clicking the right now button. Okay, that's it. I'm clicking the stop streaming button now. I can't even.